and here we go.
There's the deluge. Here's ignition.
Roger, roll, Atlantic. Doubling up.
Did it just do a Kerbal?
Back to the moon and beyond.
Put that in the big bags, you know.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect world.
Propulsion continues to be normal.
We did have an observation.
Equalizer.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center. Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes. You bet. Sure. We don't need any more of these.
It's a cloudy morning on the Space Coast. We're all up early, and that means only one thing. Something very, very special is about to happen, and that very special thing is the rollout of the Space Launch System rocket for Artemis II, the first crewed human spaceflight to the moon since 1972. It's a very exciting day, everybody. Good morning, and welcome to NSF's live coverage of this a very, very incredible operation, which we are about to witness. Now, just to set expectations, we're not going to stream the whole thing because it's like 12 hours long. So we're going to stream the start of it, and then the rest of it we'll be doing over on Space Coast Live. But it's something you will not want to miss either way. My name is Ryan Caton. Thank you very much for joining me. And we have got a selection of co-hosts for you this morning, ladies and gentlemen, to bring you through the next few hours or so. First of all, I'm going to start with the NSF debut of a commentator that you might have heard before if you've listened to some other streams, but we have Alice joining us. Alice, if you'd like to introduce yourselves to the wonderful ladies and gentlemen joining us this morning.
Good morning, Ryan. Yeah, I figured you guys needed an extra female British voice on the show, so you managed to get me up at 5 o'clock in the morning here in New Mexico to join this very exciting event. Thank you so much, and I'm really looking forward to it.
Wonderful, as always. Welcome to the team. And we have a couple of people in the field for us this morning. First of all, we have somebody, if you have technical questions, boys and girls, don't hold back, because we have Philip Sloss with us, who has been with us for a long time at this point. Philip, how are you doing this morning?
Good. I just heard somebody say that we had first motion, so we should start seeing it come out of the threshold of the VAB here pretty soon.
And we can see the mobile launcher there in High Bay 3 in all of its glory there. Mobile launcher 1, I should say, as it starts to roll out momentarily, very, 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 very slowly, as we would expect. And we, of course, also have Sawyer Rosenstein in the field for us this morning. How you doing, Sawyer?
I'm doing fantastic. It is a little chilly. I know you hear the Florida people say that all the time, but it is beautiful. And yeah, I can see the mobile launcher starting to roll out. There is absolutely movement on it. At least I can see that from my angle here. Oh, it's a beautiful day to get ready to go send humans to space.
I just looked at the weather report. It's 10 degrees Celsius, 50 degrees Fahrenheit. It's not chilly, Sawyer. It's not chilly.
It was colder than that earlier, and also there's a breeze.
Okay, maybe I'll let you have that one.
It's better than yesterday.
Just a little bit of housekeeping at the top of the show. If you have any questions or comments, of course, tag us in chat at NASASpaceflight or at NSF. We have plenty of time to bring them to you this morning with the rollout of SLS. So do make sure to do that. But I am looking very closely at the base of the MLP there and at the crawler. And Philip, I believe it is getting very close to the threshold if it hasn't crossed it already.
From my view, it has, by the way.
Yeah, they'll be going slow for until the entire thing clears the threshold. So this part will be even slower than 1 mile an hour. So, as you can see,
you have to put that in context, right? It is going to be a very slow day. This is an exciting
Yeah.
rollout, but a slow rollout.
Yeah, but they'll be going. Yeah, they'll be going. You can measure these, and you can measure the speed in meters right now, I would think. But you can see up at the top there. You can see some of the roll crew up there on the deck of the mobile launcher on the platform. Um, I'm not sure if they're the ones looking, if they're the spotters making sure that everything's clearing okay, or whether they're monitoring systems on the mobile launcher or on the vehicle. And then they probably got some portable air conditioning that they're going to use to keep some of the volumes from getting too humid.
Indeed. And we are not expecting it to head out to the pad straight away. We are expecting a little bit of a pause just after it leaves the vehicle assembly building this morning. And Sawyer, as you'll be seeing this with your Mark 1 eyeballs, I'm just wondering if you could give us a little quick explanation, quick timeline of what we should expect to see over the next couple of hours or so.
Absolutely, yes. What you're seeing now is exactly what I'm seeing with my Mark 1 eyeballs. So what we should see is it, as Philip was pointing out, taking a little bit of its extra time to roll out past the doors here. Then it will start to pick up speed, going just under 1 mile per hour, going along the crawlerway and on top of that Alabama River rock. That will then continue its roll all the way down. There's a little fork in the road between 39A and 39B. It will take the turn to 39B and head out to the pad, where it will go even slower once it goes up the incline to get onto the pad, where they will then mount it in what's called a hard down to the pad and then start connecting on the lines and getting it ready. So total time from right now until on the pad is anywhere between 8 and 12 hours, depending on if they need to stop and check things.
Plenty of time to check over everything when slow and steady wins the race in these sorts of situations, because when you have a massive rocket that weighs over 100 metric tons, you want to make sure that you don't damage it on its way out to the pad. And I think
they'll
Go
also
on,
when the entire base of the mobile launcher clears the doors, they'll probably come out a little bit farther than that, but they also will stop to swing the crew access arm to completely retract it. So they've pulled it slightly away, broke down the room, and so it's slightly away from the Orion launch abort system fairing. But when they get out the doors, then because of wind and other here, they'll fully swing it to a fully retracted position, and then they can lock it in place up against the umbilical tower. And so actually, from where I'm looking at it, we actually are we're seeing it's not its twin exactly, but mobile launcher 2 is in the background here, and you can actually see that crew access arm has been is in a mostly extended position. So they're doing some testing of that. But what will happen is they'll come out, they'll stop, they'll swing the crew access arm to swing it out. So from this viewpoint, it'll be pointing sort of to the left, and when they get done with that operation, it'll be pointing all the way to the right. And then at that point, then they can pick up and head all the way out to the pad.
And these sorts of rolls are something we haven't seen it for a little while at this point in short-term memory, because of course the last time a roll like this happened was just before Artemis I. But Alice, these have been taking place over many decades at the Kennedy Space Center. But it's something that tower on the actual mobile launcher itself. It's something we haven't seen since Saturn V, right? So it's something that's a little bit different than what we're used to through the Space Shuttle program and through, Falcon 9 and Starship, etc.
Absolutely. And there's been such a buzz around Kennedy Space Center since we've been waiting for this. I was there just a couple of weeks ago, and the crowds were just absolutely excited to see this roll out, excited to see it go to the launch pad and ready for us to take off. This has been a long time coming, like you mentioned earlier in the show. Since 1972 is the last time we sent men to the moon. And this time we're going to be sending a woman as well, which is very exciting.
Exciting indeed. We've got a couple questions about the water tank truck that sprays everywhere. Sawyer, I'll toss this one to you. Actually, we have Daniel asking, where's the tank truck? And 98 Central asking, why is water sprayed on the river rocks before rollouts? I'm just wondering if you could tackle both of those for us.
Yep. So there is, it will be, you'll see it as it gets as they go ahead, there is a truck that goes ahead of the crawler and starts spraying water. If you ask Kevin, Michael, Reed, and Das, who accidentally got sprayed by it one day, you could tell what they do with that. So anyway, as it rolls out, they spray the river rock on the crawler, kind of prepare it for the giant, massive weight that is going to be placed on top of it. Again, keep in mind, this thing is massive. This is the heaviest that has been created or has been able to be moved so far. So in doing so, they kind of wet the rock, knowing it will be crushed, and in doing so, it reduces the amount of dust that gets kicked up by it. So in doing so, again, preparing for that crazy extra weight to smash the rock into dust and make it less dusty and getting into all the gears and stuff.
And that truck you see there in the middle of the shot, that is said water truck. I'm not sure if it's the specific water truck which sprayed Das and Kevin, but it is a water truck which will be supporting today's rollout. I don't know if they run out of water and then they have to like swap them in halfway through a rollout. I would imagine it takes a lot of water to spray down the crawlerway all the way. You know, it's 4.2 miles, so I don't know.
Absolutely. They'll have multiple of them, Ryan. I used to work at Spaceport America, and when we did the cup out there and when we've done the IREC as well, we'd roll in about 4 or 5 a day. So I'd imagine they're going to have multiple on call for today.
Oh, wow. That's a lot of water.
There's a lot of dust you got to compete with, and when you're moving that kind of amount of weight, you got to make sure it's as compact as possible, which is why that water is so essential.
Something else that is essential is all of your support for us this morning, because of course we are NSF. We are an independent organization just made up of space nerds trying to bring you the best space coverage possible, and we are very grateful for all of your support, such as that from Randall, who's been gifting a Red Team membership. We've had Flippers79 McGregor gifting 5 Red Team memberships, and we have Mike Alpha Tango Sierra with the €22 super chat. Thank you very much for all of your support. I do hope that they filled up the crawler transporter last night, because breaking down because they're running out of fuel would be very unfortunate halfway there. So fingers crossed that was checked off on the checklist before they started the engines and departed the VAB. And with that, we are starting to see a little bit more of the launch tower poke its way out of the door at the moment. Of course, the door is slightly slanted on the way up, so they can fit all the panels in, but we are seeing, and I spy with my little eye, a little bit of a white SRB now poking its way through as well, which is very exciting. Should be seeing that coming out even more so over the next few minutes or so, so do stay tuned for that. We are about a quarter of an hour or so beyond first motion, which is when it moves for the first time, as you can tell by the name. I think I can also see one of the NASA helicopters up, so fingers crossed there'll be some impressive aerial imagery coming of that as well, like we saw from Artemis I. And I'm seeing some people in chat asking when it will start moving. Trust me, it is moving. You might not believe me, but if you scroll back 10 minutes or so, you'll see it was in a different position. So it takes a while, but trust me, it is indeed moving. Okay, let's see if we've got any more questions in here. We have a good question here for you, Philip. We have Supersonic Retro Propulsion. They're asking, are there any significant hardware differences in the Space Launch System between Artemis I and Artemis II?
Not any major differences. I'm trying to think if there's really anything. This is very much of a carbon copy between the first vehicle and the second vehicle. It has basically the full complement of development flight instrumentation. You'll see some little circles on the core stage as it gets farther out. Probably the biggest thing that they changed was it's relatively small scale. We might, well, we probably will get a chance to see it, but they added a pair of strakes on either side of the inner tank where the solid rocket boosters, the top end of the solid rocket boosters attach. They're, because of the scale of the vehicle, they're relatively small, but they did that to reduce the amount of buffet that the vehicle gets when it goes through the transonic region, which is just before the vehicle goes supersonic. They saw more vibrations during that part of the first launch, and so they added these strakes in the last year or so. And so, but I mean, when you're looking at it, probably the biggest change in terms of what it looks like visually is the logos that they put on it. So they rotated the NASA logos a little bit on the solid rocket boosters, the big red worm logos, and you'll see that here in a little bit. And then they added the America 250 logos also on the plus C side of the vehicle, which is the side that faces away from the umbilical tower. So really, the visual differences are more just that, visual differences than any major hardware changes.
And speaking of those hardware changes, for the very first time this morning, we were just getting a live look inside of the vehicle assembly building. And if you knew what, there we go. If you know what to look for, you can make out those new strakes. They look very small from this. Trust me, they're quite big compared to a human, but they look very small from this perspective. Those little white strakes just at the right next to the nose cones of the VA.
Yeah, the very bottom of the image of the the very bottom of the image.
Just make them out there. But of course, I'm sure we'll be able to zoom in on them and get a little bit of a better angle when it. I think the NASA Vision Mixer is having some fun there, but we'll get a better view of those. We'll get a better view of those as they roll out towards the pad. There, we'll be able to zoom in on it. But I think I can see, Sawyer, that the tower is almost fully exposed to the sun at this point as it comes out of High Bay 3.
That is correct. Again, it's hard to see the motion, but it is absolutely moving, and I think we may see it soon get ready to pick up a little bit of speed on this move. But yeah, I'm starting to see all of the work platforms as it comes out. From my side angle here, still waiting to see the peak out of the first SRB. So it's not fully out from that perspective.
Still waiting for the rocket to actually see daylight for the first time in a very long time. Because, of course, SLS takes a little while to be assembled. The first parts of the solid rocket boosters were stacking at the end of 2024. Then the core stage then arrived to meet it a little while later. And then we had the ICPS. That second stage was then stacked on top. And then we saw the Orion spacecraft being mated as well. Comparatively not that long ago. But it's a little bit of a longer process than what you may be used to with some other vehicles, but that's just how SLS rolls. Pun not intended.
You know it was intended, and it was great.
Thanks, Soy.
I'm here for all the puns. Sorry, I've got to ask. You guys have covered these sort of things all the time, and I've been there for a couple of crew launches as well. Are you seeing a bigger crowd for this rollout, or is it just kind of the same buzz? I'd love to know what it's like on the ground.
Bigger crowd is an understatement. The amount of people that are still being bussed in as we speak here to come view this, there have been cars nonstop since 5 a.m., which is about when I got here. You could still see in the foreground all those people walking around. There's giant car park to the right of me, completely full. There's tons of viewing areas. There's a bunch of bleachers. There's the media group, which is a little bit closer to the road up there. This is jam-packed. The excitement is real, and I was not expecting it to be anywhere near this busy for just the rollout.
That's really good news, though. It sort of hopefully means that people are taking this seriously, that people are getting excited about the idea of us returning to the moon and actually getting behind it. I'm really glad to hear that.
And all credit, that has been a little bit of a criticism, should we say, of NASA over the past few months, is that maybe they're not hyping this up as much as they could / should be. And, we're trying our best to hype it up because we're very excited about it. But, being able to make this accessible to the general population is something which is incredibly important, considering at the end of the day, they're the ones who are pretty much paying for it.
Absolutely. I'm really excited to hear that there is a lot of people turning out for this rollout. I'm excited to hear that people are excited. As I mentioned, I was there a few weeks ago. I went to the visitors complex with my kids, and the crowds were just buzzing. And it was nice to see that you're right. NASA hasn't really played this up as much as they probably should do. I know yesterday's press conference was a little bit of a disappointment for most of us, but hopefully we're going to see a bit of a turnaround now that Jared Isaacman's in charge.
That's a good segue, because speaking of Jared Isaacman, we have had a question from Daniel, and they are asking if Philip has an opinion on what changes Jared Isaacman might have for the Artemis program going forward. So, Philip, I'll leave that one with you.
It's a good question, which means I don't know. I would love to. I'd love to know what he's thinking at this point. I mean, has he been administrator for a month yet? So, he might still be drinking from the fire hose, but I think the obvious question right now for Artemis is, what are they going to do after this mission? They just changed. If you look at the NASA.gov website, they just recently changed the date on the Artemis 3 page from mid 2027 to quote unquote by 2028, which I take to mean by the end of 2028. And so if we just go with that, we're talking about a good almost 3 years until that mission flies. And so the question is, are they going to try and do anything in between that, or are they basically going to be waiting for a lunar lander for them to fly again? I mean, that's probably the immediate question once we see how this mission goes.
That is the big question. There has been a lot of talk about those lunar landers. Of course, we have SpaceX's Starship human landing system, and we have Blue Origin's Blue Moon Mark II, which are the current landers that are under contract with NASA. There's also been some talk, some rumors that maybe Blue Origin are trying to squeeze out a kind of half crew, half cargo Blue Moon Mark 1.5 to do a human landing in a shorter time period. So there's a lot of potential outcomes that could precede the lunar landing attempt. But yeah, it definitely feels like there's a political push, at least to get that lunar landing completed within the current administration, which of course will conclude at the beginning of 2029.
I think a lot really hinges on how the Blue Moon mission goes this year, and I think we're really excited to see how that operation falls out. We've only really just recently returned to the moon in a commercial state. When you think about it, with intuitive machines going up and Firefly, this is something that's still relatively new to the industry as of late.
And if that is something you want to learn about, there is a little cheeky This Week in Spaceflight, which came out last night, and we have a piece on Blue Moon in there, because Blue Origin have just completed some acoustic testing of their lander, and they're about to ship it to the NASA Johnson Space Center for more testing, and I will leave it at that, because if not, I'll give too much away, and there's no point for you to go watch the video. So I can assure you SLS will still be here when you get back in about 24 minutes' time. And I believe we can see a little bit of orange now peeking through the door. Sawyer, I will refer to your Mark 1 eyeballs.
Yeah, very much can see it. In fact, from where I'm at, you could see the base of the SRBs and kind of the start of the RS-25 engines, or at least where they're inside the mobile launcher there. It's interesting also to note that right now the orange tank for the core stage is very light. And that's one thing I think people forget is the Sophie, the spray-on foam insulation, starts off as a very light orange color. And then as it sits out in the sun longer and longer, it will actually get darker. So by the time if it doesn't go in the beginning of the windows here, we'll see it slowly get darker over the course of the attempts. In fact, also I can point out, I now see the NASA and ESA logo, and I'm starting to see the launch abort system at the top coming out.
SLS loves to get a little bit of a tan in the Florida sun. I think we all do, at least us Brits. But yeah, SLS making its way into the, I was going to say sunshine, but it's a little bit cloudy this morning, into the daylight, I'll say, for the very first time. And you can see from inside the VAB, it is almost, the rocket itself at least, is almost crossing the threshold there, which is very, very exciting. We're about to see this entire rocket revealed to the world for the very first time, almost half an hour or so after first motion. You can also see the new mobile launcher being built in the background there for SLS Block 1B from Artemis IV onwards. So we're going to get almost going to get a mobile launcher eclipse here in maybe an hour or so when Artemis II crosses in front of Artemis IV and beyond, which is going to be very cool to see. And we have, I'm not sure how to pronounce this, No P, sorry if I pronounced that incorrectly, but they're asking, is this the biggest rocket built so far? I'm trying to think of a way to phrase this in SLS's favour, Alice, but unfortunately, it is dwarfed a bit by not only Starship, but also the Saturn V.
It's not the size that matters. That's what we should say, right?
It's barely enormous.
It is enormous. I mean, you can't tell when you're looking at images like this on screen how enormous the VAB is. Even when you've got people in the foreground like that, I guess because they're kind of closer to the camera than the building, it's enormous. I think the rocket's 33 stories high, equivalent of a building, and it's huge in weight as well. I want to say, I'm going to have to look this up because I'm not always the best at remembering all the different weights, but it's like 11 million pounds. Am I correct? Or at least it will be when it's fully fueled. That's ridiculous.
And most of that mass will be ejected in the first 8 minutes of flight because all of that fuel will be spent, of course, and then the core stage will be sent on its way into the depths of the Pacific Ocean if it gets that far. On that note, actually, Philip, I'm wondering if you could just do a little bit of a rundown, because usually we're used to the Falcon 9, right? It launched 160 odd times last year. It is a rocket which the first stage has done its job by about 2.5 minutes, 3 minutes, and then the second stage burns up to 8 minutes. SLS has a very different kind of timeline because the core stage itself actually burns all the way until about T+8 minutes, and then it is expended in the Pacific Ocean, which, mind you, is the ocean on the opposite side of the United States. That's how long the core stage burns for.
Right. It is a. I think it's fallen out of favor is probably a little too strong because there aren't that many rockets that use a sustainer stage, but it obviously comes from shuttle heritage, where the shuttle orbiter and the external tank were essentially that sustainer stage, and then they were helped off the pad by these large solid rocket boosters. But the core stage, it starts like a first stage, and it re-enters like a second stage. So it goes from 0 all the way to when it cuts off for this version of SLS anyway. It will be at essentially orbital velocity. So, something roughly 7.8 kilometers per second. In the ballpark of 8 kilometers per second at main engine cutoff. And it will deliver this Orion and second stage into an orbit which is about 2,200 kilometers by, and I forget what the suborbital periapsis perigee is, but it's something like 30 kilometers, and so there's enough performance to put it in orbit, but it has no. Once the engine's cut off, it has no attitude control at all. So they intentionally, just like shuttle and the external tank, they intentionally stop firing the engines before it gets into an uncontrollable orbit where you don't know where it's going to re-enter, and they target a specific area of the Pacific Ocean for this vehicle, where it's gonna splash down somewhere between Hawaii and the west coast of the United States. And of course, it won't be in. It will not be in one piece when it gets there. I think people sort of confuse the way that the state that the solid rocket boosters are in, or a Falcon first stage, which gets up to a speed of, if I believe, about 1.5 kilometers per second, and how that would re-enter, and the type of friction that you get when you re-enter from that speed and that altitude versus re-entering from orbital velocity, which there won't be a lot left of the core stage when it actually impacts the water, and it'll be in too many pieces to count.
Indeed. And for a little bit of a scale comparison, those SRBs are actually a brilliant, apart from the fact that they're solid and they don't come back, they're a brilliant analog to Falcon 9 because they detach from SLS at about 2.5 minutes, which is a similar time to when the Falcon 9 first stage conducts main engine cutoff. And they're also a very similar diameter to Falcon 9. So they're similar size, and they also drop away at a similar time. So if you want a little bit of a scale comparison to a Falcon 9 booster, just imagine the SRBs are Falcon 9 boosters, and that is how big SLS is compared to that rocket, which we see all the time. And for the very first time, we can see Orion and the launch escape system and the crew access arm exposed to daylight outside of the vehicle assembly building. And that is the white room and the crew access arm, which we would expect to be retracted and stowed just after it gets out of the VAB here. So that's kind of the next checkpoint or next milestone. But that rocket is now crossing the threshold, if it hasn't already, to the VAB. So we are nearly fully outside of the assembly building. Of course, there's a little bit more mobile launcher to come out on the other side of the platform, but we are the majority of the platform is now outside of the VAB, which is very exciting to see. And that, ladies and gentlemen, is a moon rocket, which is going to launch 4 people to our celestial neighbor. And it's still a little bit of a pinch me moment every time you say that, because it's arriving. And it's, yeah, we've been talking about it for so long. It's wonderful to actually see real hardware happening.
It almost doesn't feel real, does it, Ryan? And I'm sure the crew that are there at the rollout are very excited to see it finally out in daylight, because it's one thing to see it inside the VAB, but when it is in motion like this, it's got to feel a little bit more real.
Especially inside the VAB, because for so long it has all of the work platforms surrounding it, and it's kind of difficult. Like, don't get me wrong, it looks huge, but it's difficult to get a little bit of a good look at the entire stack with all of the work access platforms surrounding it. But when it rolls outside for the very first time, you can see the entire thing rolling out as one unit, and being able to see the whole thing at once just hits a little bit different, and it's wonderful to see. It's so exciting to see. Definitely makes waking up early worth it, in my opinion.
Philip or Sawyer, can you guys see anybody on top of the launch control area doing this? I'm wondering if you've got any chance of seeing the crew, because I'm assuming that's where they might be at this point.
I can't see anybody currently on top of the launch control center. Doesn't mean they're not there. I know the team is probably also, I wouldn't be surprised if Charlie Blackwell Thompson and the team and all of them are still inside the firing room through all of this. So, but I don't see anyone out on top. There's plenty of people still here that would have been arriving in terms of the public to watch it.
And speaking of everything being in one piece, we have a new item that may be of interest to you at shop.nasaspaceflight.com. We have our Artemis II SLS assembly instructions shirt. You might know we did a Starship assembly instructions shirt a few years ago now at this point. I think it's still live in the store. But we, of course, have an SLS version as well now. So if you are interested in how SLS is put together, as we were just discussing, we made a design, we put it on a shirt. So wonderful job by the store team as usual. And you can get this at shop.nasaspaceflight.com. And there you go. You can see the boosters and the core stage being put together. You can see the RS-25s and the Orion being added in there as well, and the mobile launcher inside the VAB. And it also looks like we've got a nice little diagram of Orion flying around the moon there. So what's not to love? You can get that at the store right now. And I definitely think I will be adding that to my what's it called? My basket.
I've already got it in mind, Ryan. I'm really excited for this shirt. It's really cute, by the way.
Yeah, I always love these little designs, somewhat inspired by a famous international Swedish furniture shop.
It's not to be named. If only we could flat pack a rocket like that.
Yeah, I wouldn't really want to build a rocket out of the kind of cardboard and wooden material that they use for their furniture. Works great for furniture, doesn't really work great for aerospace. What's the word I'm thinking of? Applications.
Yes. Might be a little bit problematic. And I'm just going to say that view on the right there of having both of those in view is quite amazing. Sorry, we're getting a zoom in now of the shirt on the left. But I'm looking at both of those mobile launchers thinking this is pretty amazing to see them together like that.
Oh, if you look at the middle top at step 1, the little guy's telling you to put your spacesuit on.
You know, isn't it adorable?
I completely
Exactly
missed
like
that
that.
at first. That's awesome.
Very clever design. A big call out to the merch team.
100%. Fingers crossed yep, Chris B is linking that in the chat. So and it looks like it's pinned as well. So if you would like to pick that up, that is pinned in chat for you right now. About 40 minutes after first motion now out of the vehicle assembly building. I think it's kind of hard to tell because there are, big buildings in the way. But I think the entire thing might now be outside of the vehicle assembly building. I don't know if Philip or Sawyer, you can give us a Mark 1 eyeball account of that.
Almost. There's still a little bit of the back end of the crawler that is just at the precipice of crossing out of the VAB.
Yeah, we can just see the corner there at the bottom of the shot, ever so slightly. But it's almost fully out of the vehicle assembly building, which is wonderful to see, of course. And there we go. We can see all the various umbilicals hooked up to SLS, which, fingers crossed, they should remain in that configuration right up until launch, which could be, if everything goes to plan, as soon as approximately 4 weeks from now. But NASA is being very cautious. They're being very steady. They're not rushing anything. They are not announcing a launch date until the completion of the Wet Dress Rehearsal, which is essentially a full launch simulation up until T-minus 29 seconds, and they don't put any crew on top. So that's essentially the closest you can get to launching the rocket without launching the rocket, to make sure that all the systems, all of the valves, dare I mention the ground umbilical carrier plate for you, Sawyer, make sure that all of the umbilicals are working well.
Well, also the
Make sure
tail
there's no
service
leaking
mast
hydrogen.
umbilical. Yeah, can't ignore the
Yes.
tail service mast umbilical now as well.
Yep. I think they tried a rebrand. I'm not sure if the rebrand worked, but hydrogen likes to escape no matter what. It's a very tiny atom, and it very much thinks it has better things to do than to be contained inside of the SLS core stage. I'll put it that way. But yeah, we'll be seeing all of that testing over the coming days and weeks, and we'll of course be bringing that to you live as always, not only through dedicated streams but also Space Coast Live 24/7, which is running 24/7. So when we're not doing it yet, don't worry, but when we do spool down this dedicated live coverage today, we will of course have the live views for you to see there as well. So put it on your telly. I don't know. You can watch SLS 24/7. It's been a long time since you've been able to watch SLS 24/7. Since November 2022 is the last time we saw an SLS rocket in the flesh, and that was headed to the moon, uncrewed, of course, for the Artemis I test flight. And I think I've waffled long enough that the entire thing might be outside of the VAB at this point? Question mark.
It looks just about like it from what I can see, yeah.
Wonderful.
The
Wonderful.
vehicle is definitely outside the VAB. So now they're just trying to clear the back end of the mobile launcher and the crawler itself.
And I think the back end has cleared it.
And we're still seeing people getting waved in here, still arriving to watch the rollout. They've got here just in time. I mean, this thing is going to take 12 hours, so I think just in time there's a wide margin for being just in time to see it. But there we go. We can see plenty of people showing up.
Yeah, there are tour buses that have been pouring in nonstop. Three more of them, or four more of them, looks like, just arrived. So they keep coming.
And we can see a wonderful zoomed-in view here of the base of the rocket. We can see those tail service mast umbilicals we were just talking about there. On the left side of the rocket, we can see the base of the solid rocket boosters. We can see the aft end of the core stage. We can see all of those different tracking markers, which are used for the engineers. You can also see the little outlets. I say little, they're huge outlets of the water deluge system to suppress the sound of said SRBs and RS-25 engines. And yeah, we can see the edge of the mobile launcher platform just eking its way out of the VAB at this moment in time. And it does look a little stationary in this shot, but trust me, it is moving. Rewind the stream by a few seconds and you'll see that the rocket was in a slightly different position to the position it is now.
You can also get a bit more of a context here about how large the crawler is. I mean, you can't tell when it's next to the VAB because the VAB is so huge, but that's the size of a baseball field. And when you see all those people down the bottom there, you can start to realize just how large that whole big, massive machinery, marvelous machinery is.
Yeah. And something else we can see there on the right-hand side is the mobile launcher for Artemis IV and beyond for the SLS Block 1B. And Philip, I'll toss this one over to you because Jack is wondering, is that another SLS transporter being built with the cranes around it? Just curious. And it is indeed.
Yeah, and aside from a couple of I guess, what would you call them, stabilizer arms that still need to be added to the tower of that mobile launcher, most of the major hardware has already been either hung on the umbilical tower or installed on the deck of the mobile launcher of that second mobile launcher. So those tail service mast umbilicals that we're going to be so interested in during the tanking test, another set of those has been installed on the base, and at this point they're basically just working to outfit all the functional systems everything from electrical to computer networking and avionics and all of the obviously the propellant loading piping and all of the pneumatics and hydraulics and all of that type of all of those systems have to be completely outfitted, and then they have to be tested, and then individually, and then they'll expand out to doing more integrated tests of that. Eventually, I think it's going to go out to Pad B, and that would be obviously way after Artemis II. But I think they're shooting to have it. Bechtel, which is the prime contractor, to have it completed by the end of next year, and at that point, then they would hand it over to Exploration Ground Systems here at the Kennedy Space Center, and then they would go through a complete sort of commissioning of the mobile launcher at that point, in parallel with the SLS Block 1B vehicle getting ready for its first flight.
There's going to be a little bit of a pause between Artemis 2 and Artemis 3, so might as well take advantage of the pad while it is available for all of that pre-flight testing and commissioning. So that would be something else which is impressive to see, because this mobile launcher, which we're looking at right now with the SLS rocket on board, has been out to LC-39B a couple of times without SLS on board. It was out there actually all the way at the back of October 2023, because I was fortunate enough to see it in person, and that was a good year or so after Artemis 1, and it's also been out there for some testing since. We covered that rolling back. Oh gosh, I can't remember. It was a few months ago at this point. Was it last year or 2024? I can't remember, but we did cover that early morning return of the mobile launcher to the VAB. And we have a question here from Ziggy Sawyer. They're asking, why do they use river rocks for the crawlaway and not pavement?
Well, you want something that can take the weight of the mobile launcher and, of course, the rocket on top. And you also want something that is not going to crack and create all these potholes and run the risk of it falling and, getting stuck, things like that. So with the river rock, it's a special rock that is basically designed to crumble away. And it goes a couple of feet deep into the ground under the crawlerway. So that way it goes on top, and instead of, destroying pavement, creating potholes, it just crushes the rock, basically turns the rock into sand and dust. And as we pointed out earlier, they spray it ahead of time so that dust doesn't then get into all the gears and cogs and everything.
And that is a lot of river rock because, of course, it's about 4.25 miles all the way out to Launch Complex 39B. And, of course, there are two sides to the crawlaway, so you times that by 2. And then you think it's 2 feet deep, and it's several feet wide. And that's 2 big trenches you've got to fill in with all of that Alabama river rock. Okay, I'm going to go over a little bit more support we've been getting. We're, of course, excuse me, very grateful for everybody's support this morning, waking up early to see the reveal of SLS ahead of Artemis II. We have Kevin thanking us for the coverage. Well, thank you for tuning in. Michael has become a Capcom member, and that means you get access to our member Discord if you are interested in that. 33 Raptors Mimi thanking us for the coverage again. Well, thank you for watching. Bideford, someone who is always in chat, thank you for your ongoing support, Bideford, as always. It's always wonderful to see your name, and we are very, very excited for this future of space exploration to the moon, Mars, and beyond, as is kept being said, of course, by the officials. And thank you Gus for the coverage as well. Thank you for watching. I feel like this is going to be a very repetitive phrase here this morning. Hop Hayes with the $5, and they're asking if we could compare the time difference to get to the moon between the last Apollo mission and Artemis II. Cheers from Indianapolis. Well, Philip, Apollo, it felt faster. I'm not sure if it was faster, but they were definitely squeezing in more flights of the Saturn V than they're squeezing in of SLS.
Well, if the question is referring to how long it takes the transit from the Earth to the Moon, Apollo did it a little faster than this vehicle will. I want to say, well, I think they're talking about the lunar flyby day being on flight day 6, and I think if you recall, the easiest one to remember is Apollo 11, just because the dates are we recited more often, but that lifted off on July 16th, 1969, and they actually landed on the moon on July 20th. So in between, they had to insert into lunar orbit. So if I recall correctly, the transit time was usually on the order of about 3 days from the Earth to the moon, and from the moon to the Earth. And so this one's going to be more along the lines of 4 or 5 days, and it'll be dependent on when they launch in a particular launch window.
It's also worth noting that this one isn't going into lunar orbit. It is going about 7,500 kilometers from the other far point of the moon. So it's not doing quite the same mission trajectory as what we saw for the Apollo missions.
Right, that's correct, and it's a different. These are different styles of orbits, and it's also it's good to point that out too. And one of the things also the other thing that they're talking about that's different from you can't really call any of these standard launch flows because this is only the second one, but they're going to do this wet dress rehearsal tanking test that they're going to do is essentially a full countdown with a 2-day run up to it, and then after you it essentially ends with a intentional scrub, and so they have to detank and they have to let everything settle down and boil off, and so they have to do that and then turn around and then do a launch countdown after that. And so the question is, do they have enough time? They were talking about doing a tanking test at the end of January, early February, which gives them about 2 weeks. And so they have a decent amount of work once the vehicle gets out there. And I think the uncertainty is, can they get ready for the wet dress rehearsal in 2 weeks, and then obviously getting over the hurdle of the tanking test. This will be the first time they've fueled a vehicle in more than 3 years, I guess now. And so, are there any issues with that? And then one of the things that we heard yesterday from Charlie Blackwell Thompson, who's the Artemis launch director, this is just something that I wasn't aware of, which is that for the wet dress rehearsal, the crew's not going to go out to the pad, but the closeout crew is. So the closeout crews, when the vehicle gets into stable replenish, which is basically when the tanks are full, and then they're just replenishing the boil off for the core stage and for the interim cryogenic propulsion stage, which is the in-space second stage for SLS. Once they get to stable replenish, they will release the closeout crew, and they will go to the pad and they'll go through the entire sequence of closing Orion out on launch day. And really the only part that they're not doing is they're not doing the crew ingress, but that only probably takes up about, if it's nominal, that takes up about half an hour of a 4-hour timeline. So they're not doing that part, but Andre Douglas, who's the U.S. backup crew member, he's the astronaut support person for the closeout crew, and so he's going to go into the crew module. He's going to make sure, just like on launch day, he's going to make sure all the connections and all the cabling is configured for crew ingress, and then they will go through the whole procedure to prepare the Orion hatch for closure. They'll do a cabin leak check, and then they'll close the LAS hatch, the launch abort system hatch, and that takes quite a bit of time. So those are probably the two areas that I think they want to make sure that they have that down sort of relatively well. And so assuming that the tanking of the vehicle of the two stages goes relatively well, they don't have to fix anything, and that they don't have any procedural or other fixes that they need to do with Orion, because they didn't have to do this for Artemis I. Then they would be ready to go pretty much after that happens. And so obviously, if there is something they have to fix, then the question is, can they do it fast enough to get in launch attempts before the end of the window, which is February 11th, but really it's the night of the 10th. And so the February launch opportunity is 5 consecutive nights, beginning on the night of February 6th, at least local time here in the Eastern time zone. So the night of the 6th through the night of the 10th. So if they end up needing like a week to do something, to fix something, then it's probably going to be difficult for them to get a launch attempt in. But the fact that they're rolling out today means that they think they've got a decent shot, or otherwise they wouldn't have done this.
Yeah, I guess I was playing devil's advocate there. We're just appreciating how many steps there is to go before we see launch day, and I'll let Ryan take over from here.
Yeah, I will just quickly apologise. We did have a little bit of a technical difficulty there about 5 minutes ago, but we appear to be back. Those of you that are members will, of course, know that we've been building up some new infrastructure to bring these streams to you. So, well, it's better it freezes now than at T-0 on the Artemis II stream, I'll put it that way. But we are working through some problems, and Yeah, so apologies for that, but we should be back in full high definition, smooth 30 frames per second. So there we go. Just about an hour now after first motion of SLS, and it is fully emerged from the VAB at this point. You can see it there standing proud on its mobile launcher with the crew access arm still attached to the launch escape system hatch. We should be seeing that swinging back a little bit later on. And I also believe in about an hour's time, there is a pre-planned media event with Jared Isaacman, the NASA administrator, and all 4 crew members of Artemis II, Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen. So we will be bringing that to you, assuming that we do get the feed for that, which will be very exciting indeed. And this is a view you don't get to see every day. You can see LC-39B in the background, the VAB, of course, in the foreground, and the SLS just starting its journey out to the launch pad ahead of what will be a much longer journey around the moon, potentially as soon as about a month from now. So yeah, as Philip was saying, they're rolling it out now. So it sounds like they have confidence, that NASA has confidence that they'll be able to reach that milestone.
It looks like the crew access arm is starting to swing.
It definitely is.
I'm looking. I'm taking a peek over to the countdown clock over here, which I believe is where they were planning to have the event with the crew, and it's, at least right now, looks pretty quiet over there. But I guess they have an hour to get set up for that.
I'm not sure if you get a slightly different angle just to take a look at the crew access arm, but there we go. You can definitely, yeah, we go. It's clear as day now. That crew access arm is swinging back to be stowed in its kind of rollout position, and that'll give us an even better view of the top of SLS, slowly making its way back there.
I must say, as slow as the crawler moves, the crew access arm has some speed to it, which, again, this is more like the speed that we'll see on launch day after the crew is on board and they move it away. But one thing that's also important to note is that as kind of slowish as it moves away, it can go back within a matter of seconds. In the event that the crew needs to egress for some emergency reason at the pad, they can swing that arm back in a matter of seconds.
And there we go. It's almost 90 degrees now, perpendicular with the tower. It's got the flashing lights on as well to make sure that nobody crashes into it with their aircraft. I will say there are many hazard warnings in the area, not only for the sky but also for the sea. For security purposes, NASA is making sure that nobody who shouldn't be here isn't here, and is keeping everything safe. We can also see a crew of people up there right next to the crew access arm on board the tower there, monitoring the retraction as it folds back in. Looks like it just paused there for a second maybe, but that should swing back all the way to be kind of level and flush with the tower for the rollout. So we will keep an eye on that as it continues. But in any event, we have another question here, and Philip, I'll toss this one to you again because you haven't had enough questions today yet. We have Kevin asking, how do the boosters of Artemis compare to the SRBs of the space shuttle? I think they're similar, but they're just a little bit bigger. Am I correct, or am I mistaken?
It actually uses space shuttle hardware. So these are the cases and the nose cones and the aft skirts that flew on the space shuttle, flew on space shuttle launches. And in the case, there I think are a few of these cylinders that may not have flown, but all of this equipment was manufactured during shuttle. And then obviously they have to reload them. The biggest difference between shuttle and these are 5-segment boosters, and shuttle used 4 segments in the motor assembly. So you've got the nose cones, the forward assembly with the avionics on top, and then you have the aft assembly with the aft skirt and the hydraulics and some of the separation motors in both of those. And so really this is just this is a longer version of the shuttle solid rocket boosters, and then with the tweaks that they had to make, you have to adjust the internal shape of the propellant inside the booster to to tailor it to this vehicle, and the fact that it's also producing more thrust.
I think the crew access arm is just moving again, or it's the wind. I can't tell. There, yeah, it's swinging back. There we go. You can see there, just making its way ever so slowly to be fully stowed away before continuing the roll to 39B. And in just a second, we should be able to see the hatch. There it is, fully revealed. That is the hatch on the launch abort system, because of course that fully encases the Orion spacecraft, which is inside of that protective kind of fairing there. So there's a hatch inside the abort system, and there's also of course the hatch to the Orion spacecraft. So there's two hatches in there, and that one we can see is the kind of the outside shell, and we can see for the first time fully revealed the launch abort system sitting at the top of the SLS rocket for Artemis II. Looks like they might be kind of pulling the crew access arm back in stages here. Because it looks like it has paused again. But they've got plenty of time. They're not in any rush, so nothing of concern there. In the meantime, we have gotten a little bit more support. First of all, Kristen, I believe, is the first person in chat to have purchased the brand new SLS assembly hoodie. So well done, Kristen. Thank you very much for that. We have Aska becoming a PadRat member. More PadRat members and Capcom members coming in. Thank you, Tia, for joining the membership program. We have Shard Stars Space, and they're asking what type of fuel does Artemis II use? Well, Sawyer, there are various different commodities used throughout SLS, if you would like to very quickly take that one.
Yeah, so if we're talking the solid rocket booster, of course, use the solid propellant, which is kind of like I guess a peanut butter consistency is the best way to describe it. But the main propellants, especially for that giant orange tank that you see there, is going to be liquid oxygen as the oxidizer and liquid hydrogen as the propellant. So it burns a lot clearer looking compared to what we're used to seeing, say, with Falcon 9 or even the Methalox rockets like Starship. So that's primarily what you'll see for those main tanks there. And then for once they're in orbit for other kind of transfers and things like that, they have hypergolic propellants on board Orion for those kind of maneuvers, especially for when they do the proximity ops, as it's called, when they'll basically practice using those thrusters as if they were to rendezvous and dock with a Starship lander or a Blue Moon lander, obviously without the lander.
Yeah, they're kind of going to be flying around the ICPS upper stage, kind of pretending it's a lander, but just to get used to and get kind of first-hand experience of that Orion, the handling, I should say, of the Orion spacecraft. I can't tell if it's the heat haze or if the arm is moving again. I think it might be my imagination. Yeah. Okay, let's see. And we have Charles Harms asking why we aren't using Starlink. We do use Starlink. We use Starlink all the time. We have Starlink at all of our sites and other various locations. We make great use of that satellite internet when it is available. Of course, also using the more terrestrial networks that are available as well over the mobile carriers. So there we go. We're just over an hour now. Only 11 hours to go. Luckily, we won't be live doing commentary for the next 11 hours, but we will, of course, be carrying that on Space Coast Live, our 24/7 cameras of the Space Coast. and I'm pretty confident in saying that we will have a camera trained on Launch Complex 39B as much as we can, because that is something that's going to be very exciting to see. And am I imagining things, or is the arm going back?
It seems to have some
It's
kind of movement.
it's very windy out here right now, so it could just be
Ah.
shaking in the breeze. But also interesting to note that I'm seeing people just walking around on the deck of the mobile launcher, and it's kind of just funny when you get the humans for scale, so to speak, to actually be able to see these tiny little people walking around this giant moon rocket.
Yeah, it definitely looks like it is going back now into its uh, kind of Orion access configuration. There we go. Okay, in the meantime, I'm going to see if there's any more questions. If you're just joining us, first of all, tag us in chat at NASASpaceflight or at NSF. At this point, I think I will also reintroduce Alice, because we have got a few more people watching us now than we did at the start of the stream, and it's always wonderful to introduce a new voice. So Alice, once again, if you wouldn't mind, for the wonderful boys and girls joining us this morning, just wondering if you could give us a little brief introduction of who you are.
Thank you so much for that, Ryan. Yes, I'm Alice Carruth. I'm a space communicator, I think is the term what I kind of call myself. I've done a bit of everything. I've worked at spaceports as a PIO. I've worked at comms for space companies. And I currently produce the T-Minus Space podcast, which we are partners with you guys on. We've obviously taken your space traffic report and we release that every week on our podcast. So it's really great to be partnering with you on your live stream for a change.
Indeed, it's wonderful to have your voice on the stream. It's always wonderful to grow the team. So first of all, welcome, and fingers crossed. It's an exciting. I mean, it's a good time to join because we've got some big events coming up over the next few months. It's a busy time, so the extra pair of hands is very much appreciated as we prepare for the launch of Artemis II. Someone else that's preparing for the launch of Artemis II is, of course, Commander Reed Wiseman, and according to his most recent post on social media, he is very excited for the rollout of Artemis II. He just posted this picture from inside of the vehicle assembly building, and I have to say, that's a pretty spectacular shot, looking on at the rocket as it makes its way out in the morning. The crew flew in from Houston last night to prepare and witness their rocket moving down the crawl away, and that is, yeah, somehow he managed to catch some blue sky in his picture. I have not seen any blue sky this morning, but maybe the blue sky is ahead.
It's the other way round. It's the different view from the VAB. It is a great image, and it answers our question: where are the crew right now? Where are they watching this from? So they've obviously got the front row seats in the VAB. Lucky them.
By the way, there absolutely is blue skies. It's kind of on the other side of the VAB right now, so the clouds are kind of looming over 39B, but moving from the west towards the east, it is absolutely some blue skies, little thin, wispy, puffy clouds makes for a gorgeous backdrop.
Sawyer, are you warming up yet?
No, absolutely not. I just put my hood on, my sweatshirt that I had from shop.nasaspaceflight.com.
Have you got your Artemis assembly sweatshirt, though? That's the question.
No, not yet. I do have some Artemis merch in the mail coming, but I don't have anything yet.
I wonder if we can get that image up again of our merch that we've got for today. There it is. Such a cool image. Such a great t-shirt and hoodie options.
Indeed, the store team. The store team. Well, I say this. I didn't expect the store team to do a good job, but they always do a good job. But the store team, especially this time, did a very good job of of this particular design. If you're interested in building your own SLS at home.
Wondering if anyone's going to flat pack it for us and send us an image.
Yeah.
Build your own.
The crew access arm is retracting once again. Maybe they're just testing out the hinges, maybe? I don't know. But they pulled it back and then they pushed it back in, and now they're retracting it again. I'm wondering if they'll go all the way to the fully stowed position this time, but we'll just have to wait and see. They're definitely keeping an eye on it. There's some teams up there on the mobile launcher tower. Is it going all the way this time? It looks like it might be.
It's moving with haste this time, isn't
It's
it?
still,
Yeah.
yeah, it's still going.
Has a lot more
They're going to
momentum
be
than it did the
doing.
first time.
They're going to be doing a lot of swing tests out of the pad once they get out there.
Yeah, that's what made me think maybe they're doing some testing now, or just trying to make sure that it's, not the hinges haven't rusted or something. I don't know. I'm just making this up, but you can see there the interface between the hatch and the white room there on the end of the arm, and that is quite cool to see. Definitely looks like it's going all the way back now, this is kind of the first checkpoint, so to speak, if you were just joining us. So we had the first motion just over an hour ago now, and the rocket was revealed to the world as it exited the vehicle assembly building about 7 o'clock. That was first motion this morning, and just over the last hour it's been emerging. Then they pause, they swing back that crew access arm into its stowed position, so it's all secure, and then they continue the roll all the way out to 39B. And it looks like it's fully swung back. There you go. And that'll give us the opportunity to get some wonderful pictures of SLS as it rolls past. I'm sure there'll be plenty of pictures headed to the various membership areas and social media, of course. So if you're a member, keep an eye out. And of course, if you are not following us on your favorite social platform of choice, then I recommend that you do.
Yeah, I realized I was actually unmuted as I was taking some photos there. Apologies if you heard the shutter clicking.
It's nice to know that we are getting some photos, Sawyer. Don't worry, don't worry. So we have some great questions here about the crawler itself. So I'm just going to run through these. First of all, we have 9-8 Central, and they are asking, will this be the last time that the Mobile Launcher 1 will be used? Philip, I believe it's going to be used on Artemis II, and I'm not sure if they're going to retrofit it for Block 1B, or if it's only going to be Mobile Launcher 2 for Block 1B.
It's the Mobile Launcher 2 will be for Block 1B, and then in theory Block 2. But yeah, I don't think they have any. They maybe have some wishes about being able to reconfigure Mobile Launcher 1, but I don't think have any concrete plans to do that. And in terms of the crawler Transporter 2 is the one that's going to be used for both, and that's already been modified to handle the load for Mobile Launcher 2 and for the Block 1B, and also in theory the Block 2 vehicle.
Indeed, and along those lines, we had a WG Mojo saying, quote, tell us about the Apollo era thing carrying it. I believe the Apollo era thing, quote, is in reference to the crawler transporter. So Alice, I'm just wondering if you could tell us about the crawler transporter, which has been used for many decades at this point, carrying various rockets from the VAB to Launch Complex 39.
It absolutely has. It's the Crawler Transporter 2 that you're looking at today that they're using, which was built about 50 years ago, but has been upgraded multiple times since it was first used. It's, as I mentioned before, about the size of a baseball field. And its speed is a whole 1 mile per hour when it's fully loaded, but it does double in speed if it's unloaded to 2 miles per hour. I mean, it's a Speedy Gonzales vehicle. It is an engineering marvel by itself. Forget the rocket. The crawler itself is just incredible to see. And I'm really excited to see it being used again for a lunar launcher. I believe it weighs somewhere around £6 million plus, which is just crazy to think, just that alone, and has about a height of around 26 feet when it's fully at its full height. And it's carrying, obviously, the Mobile Launcher 1. When it gets to the launch pad, it will then hand over its power to the launch pad and crawl away and go back to where it's going to be stationed while it goes into launch mode, which is pretty exciting to see.
And we have another question here from Craig. They're asking, does the SLS launch from the crawler, or is it somehow removed before launch? Well, Sawyer, the crawler itself is independent from the mobile launch platform that SLS sits on, right?
Exactly right. So the crawler transporter kind of crawls its way into the VAB and then plants itself underneath the mobile launcher. And again, hence the name the mobile launcher. They are able to secure it to the mobile launcher underneath, kind of jack up to it, lift it, secure it in place, roll it out to the pad, and then once it's at the pad, they will do a hard mate to the actual surfaces there, leave it at the pad, and then the crawler will again just lower its jacks and move away and head back and out of the way.
And it almost, from this perspective, looks like the huge crane in the background is hooked up to the top of SLS. I can assure you that is just perspective, and that crane has nothing to do with today's operations. That crane is supporting the stacking of Mobile Launcher 2, which, as Philip was talking about just a moment ago, is the new mobile launcher going to be used for Artemis 4 and beyond for Block 1B, and I suppose Block 2 if they get that far, but that's still yet to be seen. I believe there's only really a little bit of funding up to Artemis 5 at this point, so we'll just have to wait and see on that one. But I'm sure there's other things, more positive things we can talk about in the meantime.
I just looked up some stats for you, Ryan, about the CT2. There you go. It has to date travelled 2,335 miles. I think that's quite impressive, given how slow it moves.
Yeah, I would hate to do the calculation of how long it's taken to do that mileage. Definitely.
At least 2,000 hours
Mm,
if it's going 1 mile per hour.
yeah, it's the only speed you really measure in days rather than hours.
Yeah.
About what would it be if it could do 4 miles in 12 hours? What's that? 8 miles per day?
Bonkers,
Not the
isn't it?
fastest machine in the world,
It isn't.
but it serves a very special purpose, and it performs that purpose very, very well. Tried and tested, these machines are, having carried multiple moon rockets, multiple generations of moon rockets now, of course the space shuttle as well, and the best rocket, Ares 1X. And swiftly moving on before anyone cuts me off. We have Jason, who has become a Padrat member. Thank you for that, Mr. Fluffy, with a $5 super chat. Thank you very much. You are very welcome for the stream. They're asking, ask Sawyer what he would think of a Vandenberg SLS launch. I'm not sure if it would ever launch from Vandenberg. I don't think that's really on the cards for SLS, unfortunately. But yeah.
Right. I mean, there's no need for it because Vandenberg is primarily used for polar or sun-synchronous orbits. This one, you need a translunar injection opportunity, which you wouldn't be able to get from the West Coast. Part of why I believe the East Coast is the best coast. But yeah, SLS doesn't make sense to launch from the West Coast. Also, to be able to build and assemble it out there, there really isn't something like the vehicle assembly building that you have here to be able to do that. There originally was a plan to launch the space shuttle out of Vandenberg over at Slick 6, but that plan was scrapped after the Challenger disaster.
And we have Diamond Paint with Diamond Dave with a $5 super chat asking, why do they retract the crew access arm during transport? Can it not stay in the crew entry position? Well, Alice, I think it's pretty much just to protect the arm. They don't want it, if it's windy, they don't want it swinging out. They just want to lock it in position, right?
Any kind of, you can imagine this is going to have a lot of motion, even though it's moving very slowly, the whole vibrations of it, you don't want that to start pushing against the vehicle and causing any damage. So it's just safer to retract it at this point so that it doesn't cause any further damage.
And they're not
Safety in
going to be needing
abundance.
100%, and they're not going to be needing to access Orion until they get to the launch pad. So there's no need at all. You know, it's a retract arm for a reason, so it can get out of the way, particularly on launch day when those SRBs are flying past, but also before the launch as well. So it's good to see. Cautiously optimistic that we will see the pace picking up once again shortly with that arm now retracted and stowed. If it's not moving already, the problem is it moves so slowly sometimes it's difficult to tell. But we will stand by and keep an eye to see if it is crawling or if I am seeing things in my imagination.
I think you might be imagining things. Sawyer, how many people are there? It looks like every time we see images, there's people everywhere.
Yeah, by the way, I do not see it moving yet either. The people keep coming, and they don't stop coming. It's unbelievable. There's an area to my right that is a giant lawn that's sometimes used for launch viewing. It is completely filled with cars of people that had passes to come here and see this. Again, you can see the people absolutely lined up in the shot that we were looking at just before, and that's only some of them. There's more off to the side. There's more all the way down the road. You could see there in that shot. There's even more to the right of it. It is unbelievable the amount of people. And again, the visitors complex buses just keep arriving with more people. It's impressive and exciting to see just the amount of hype that there is around this launch.
And Sawyer, this isn't like a general admission, general public thing. This is literally NASA employees bringing their family and friends along to come and see the machine they've been working so hard on finally be revealed to the public for the very first time, right?
I don't know for certain, to be perfectly honest. I believe so. But yeah, certain car areas, they'll need to have special passes. Those are usually the employees and their families, but I'm not sure about the people that are continually bussed in.
The media complex, I bet that's busy as well, because I've seen this across mainstream media for days, which is really exciting to see that they're getting behind this.
There it is. By the way, you can see me waving. That's just the number of cars off to my side there.
I can't. Sawyer, forgive me, but I can't see you. I'm trying to find you. I'm looking.
I guess I'm
preview's
blocked by
too
a
small.
bus. Anyway.
Oh, you're blocked by a bus. Oh, poor Sawyer. I'm having a look I have a cheeky look at the Kennedy Space Center visitor complex website. I'm trying to see if this was open to the public or not. 'Cause if it was, I completely missed that. But I'm having a quick look. I can only see launch viewing opportunities, so yeah, I don't know. I'll leave that. I'll leave it at that because I can't figure it out.
What a day to go and visit the visitors complex to be able to see this rolling out.
Yeah, I
Even
mean,
though-
it's quite hard. No matter where you are in Titusville, this thing is going to be pretty hard to miss, right?
Absolutely. Even from when you get to the visitors complex, you can go out to the historic launch pad 39. So you're pretty close. I'm sure that today is going to be a different setup. They might not be accessible as normal, but even from where you're sitting at the visitors area, you can probably see the whole thing roll out, which is going to be amazing.
Something that is moving, if it isn't the crawler transporter, is the VAB door to High Bay 3. You can see the top two panels have now been closed off, and the third one is on its way as well. So those will continue moving downwards to enclose High Bay 3 for hopefully the final time. I'm going to be optimistic and say that we won't have any aborts or testing gremlins or anything that requires a rollback. So I'm going to be confident and say that they'll be able to. This will be the only time SLS will be rolling out for this mission. I don't want to jinx it, but I'm going to have some positive affirmations about this. Because Sawyer, one of the reasons they had to roll back so many times last time was because the FTS, the flight termination system, kept expiring. But this time, they've thought ahead, and I believe they've added a new access platform that allows them to recharge or re-verify rather the FTS on Artemis II.
Yeah, part of it was the flight termination system battery, which has a set lifespan on it. They were able to, for a couple of the attempts last time, get a waiver from the Space Force to say, yeah, it's fine, you can still leave it out there. But once there was a hurricane that came through, they took the opportunity, and that time while it was rolled back, actually were able to change out the batteries on that. So this time they've allowed it so that they can do that at the pad. And in fact, they've added a bunch more platforms to try and make it easier for any repairs that need to be made to do them out at the pad to try and prevent a rollback into the VAB at all costs.
And I am really hoping they get rolling again soon. But we have, of course, the media event with Jared Isaacman, NASA administrator, and the crew of Artemis II, Commander Reed Wiseman, pilot Victor Glover, and mission specialist Christina Cook and Jeremy Hansen. They're going to be talking with us and the other members of the media in about half an hour's time over by the famous countdown clock at the Kennedy Space Center. So we will be bringing that to you, so do stand by for that. And we will be able to, fingers crossed, hear from the newly appointed man at the top and the 4 people who will actually be flying on top of this huge machine. Maybe as soon as the beginning of February, maybe February 6th, maybe February 8th. We're not too sure because NASA is not setting the launch date until the wet dress rehearsal is complete. They want to be cautious. They don't want to set any kind of unachievable dates or so. So they have various windows available to them, which they have published so far through April. And there is that clock on the right-hand side of the screen. Looks like there might be some cameras being set up in preparation for that event. And looks like NASA also has a little count up probably from first motion there, which took place about 7 o'clock this morning, local time, about 90 minutes ago. And I will look through for some more questions. If you're just joining us, feel free to tag us in chat at NASASpaceflight or at NSF in the YouTube chat, and we will bring them into the queue and answer them to the best of our ability. Sawyer, we have a question from MCC Saxman. They're asking, what is the temperature currently? How cold is it? Lots of people in coats, question mark. You'll say it's cold. I disagree that it's chilly, but apparently it's chilly.
It is definitely chilly out here, I have to say, yes. For Florida people, especially. Yeah, and with the breeze, it makes it colder. It is warming up, though. Now that the sun's coming out, it's definitely warming up.
Hopefully you'll be able to take off your jackets and be in T-shirts in January, which is a completely foreign concept to somebody like myself. But there you go. Let's have a look through here. Oh, this is a good question to throw around the room because we have Luke asking, how many launches of each SLS variant do you think we will see before it is retired? Alice, I think it's fair to say that SLS isn't the future of space exploration, so to say, considering it's a fully expendable vehicle based on space shuttle technology from 40, 50 years ago. But how many launches of SLS do you think we'll get to see before it's retired?
I think we're going to. Oh, it's a really difficult one to answer, isn't it? We want to be able to see it used because we've invested so much money into it, and we know it's a workable vehicle. Hopefully, this all goes to plan and comes back exactly the way it's supposed to. And I think if that is the case, they're probably going to use it at least, I think, 3 more times. But we'll see. It really depends on what the competition's going to do. We know that Starship is readying itself to be able to come in and do this, but it's not there yet. And NASA certainly isn't going to switch over until we know for certain that everything is exactly the way we need it to be. What about you? What do you think?
I have a feeling that I kind of agree with you there because we've got funding so far up to Artemis 5 in various forms. I think 3 more flights might be the call for SLS because at that point we're going to be like into the 2030s, right, with Artemis 5. So I think there are going to be other commercial options well and truly tested by that point. And finally, we have motion once again from SLS and the crawler. It is rolling to Launch Complex 39B. The crew access arm has been stowed. The VAB door is being closed. And we are very well off and away now at this point. Down the crawlerway, making good pace at just under a cruising speed of under a mile an hour. Sawyer, how's this looking from your perspective? Again, this might be my imagination, but it looks faster than when it first came out of the vehicle assembly building just about an hour ago.
Oh, it absolutely is. And again, that was part of the plan, is to go a little slower, getting out of the building, make sure everything's good to go, then retract the crew access arm. And now that it's retracted and likely locked into place there, they can pick up the speed, put the pedal to the metal, and go 0.9-ish miles per hour. Which, for reference, normal walking speed is about 2.3 miles per hour. So, yeah, just for comparison there.
Yeah, if you're prepared to walk 4.2 miles, you can very easily beat SLS to the launch pad. Yeah. I'm also curious if we will see any banners on the mobile launcher, because as was customary over the shuttle program, and we also saw on Artemis I, they put a little banner, I say little, quite a large banner on the side of the mobile launcher. So it'll be interesting to see if that is also the case this time around.
What's also interesting is they have different banners located around the press site area here and around the VAB. There are giant banners representing each of the NASA centers and each of the contractors that worked on Artemis II. And every single one of them is signed by the teams that worked on it. So it brings a real human aspect to everything here, just to look around at every fence there is and just see, heat shield team, to see the booster teams, to see, all of these different contractors, L3 Harris, Boeing, signed by the people that worked on it. It really, again, it just makes it feel more like a human vehicle.
Indeed, it's really important to show all the various, thousands of people across the US and internationally who have made this vehicle happen, because we have the core stage, for example, is built by Boeing. We have the ICPS second stage built by ULA. We have Orion, of course, built by Lockheed Martin. And we have the service module built by the European Space Agency in Germany as part of the ESA's contribution to the mission. Of course, we have Canada's contribution to the mission in the form of Jeremy Hansen, one of the crew members who will be flying as a mission specialist. And of course, we have all of the other subcontractors around the world helping to build components for all of the various, much bigger components of the Space Launch System. As it makes its way around the corner now, we should see it turn left momentarily. It's kind of on a little bit of a kind of an elbow kind of shape of crawlerway as it comes out of High Bay 3. It's offset from the crawlerway, so it has to kind of do like a little S, much slower than a Formula 1 car, and then it will go straighten out and roll down the Saturn Causeway and the crawlerway out to 39B.
Love the way we keep talking about how slow it is. I think I'm going to add it to my resume from now on. I can actually outrun a crawler.
This thing's beautiful.
It is, isn't it? What an absolute engineering marvel. I keep saying it, but it's true.
I can outrun an SLS.
Only on the crawler, though, Ryan. Only on
the ground. Okay, and speaking of the route, I believe Jay, our wonderful producer for today, has queued up a cheeky little graphic I made the other night showcasing the route of the rollout. If you were previously unaware, this is where SLS will be rolling and approximately at what time it'll be making its way out. So, where are we now? 1 hour and 38 minutes, so maybe I was a little bit optimistic here, but it will be rolling out to 39B. It'll go round that little kink in the crawlerway, then it'll go straight down in the direction of 39A, but then it has to make a left turn, because of course we're going to 39B, so it will make that left turn and then head down the track to 39B. You'll actually see there's a little stub there, kind of a third of the way down that track to 39B, because originally there was going to be a couple more launch pads. There's going to be 39C and 39D at Launch Complex 39, but unfortunately there was only the funding and commitment in the Apollo era to build the first two launch pads. The second two were never constructed, but just in case they were going to be built, in a little bit of forward thinking, they left a little stub of crawl away just in case they would ever need it. At this point, though, I think it's probably unlikely that they'll ever be built in that form, but the area north of the Kennedy Space Center has been kind of tapped previously to host Launch Complex 49, I believe it is, which could potentially be like a huge 6 launch pad Starship launch complex, which would be kind of incredibly impressive. But whether that actually materializes is yet to be seen. SpaceX, of course, focusing on their pads at 39A and Space Launch Complex 37 a few miles down the road on the Space Force side of things. So we'll just have to wait and see if that ever materializes north of 39B. And I can see some blue sky, finally, from our cameras.
Blue sky and lots of vehicles and lots of people. I'm really excited to see how many people have turned out for this. It's great to see this kind of support.
Indeed. It sometimes feels like, especially when we have Max and D rolling out to the press site for the midnight and 3 a.m. Starlinks, sometimes feels a little bit abandoned because there's literally nobody else about apart from the 2 or so people covering the launch. But this is the polar opposite to that. It is wonderful to see, and there's another bus arriving. So many people turning out to watch this rocket roll past, and it's a wonderful opportunity for all those who worked on the program to get up close and personal with the rocket they helped to build. And this is a machine. But like, we haven't been able to say this since 1972. We can see a machine in the flesh which is going to take people to the moon. We haven't been able to say that for 53 years, and that is just incredible.
Yeah, we kind of can't skim over that, can we, really? This is the first time since 1972 that we are sending humans beyond our Earth's orbit out to our neighboring celestial body. It's going to be an amazing mission to see, and I'm sure the crew are buzzing right now to see the vehicle in the flesh, out in daylight. I mean, they watched it from inside the VAB, and now they get to see it on its rollout to 39B.
Let's have a look through here very quickly. DM Delia becoming a Pad Rat member. Thank you for that. And we have a question here from also DM Delia. Welcome to the chat. And they're asking, what will NASA do after Artemis II? Is the goal to land on the moon? Alice, that is the plan. Artemis III is currently scheduled to be the first lunar landing attempt. And, well, I hope it goes off successfully. But yeah, that is the current plan.
That is the plan. As Philip mentioned earlier, they have moved back when that will happen. At the moment, if you go to nasa.gov, they're saying by 2028. We'll see. It really depends, I think, on how this mission goes. I think at the end of this, they'll evaluate exactly when they think they can move this up to and have a realistic goal of when they can land humans on the moon. We don't even know the crew for Artemis III fully yet, so there are rumors, but to actually have the crew ready, I'm sure behind the scenes there are folks that know exactly what's going on with it, but officially we're not too sure. Look at that shot. That's a great shot up close of seeing the crawler in motion.
And you can even see flapping in the winds those little red remove before flight tags on the aft end of the boosters there on the SRB skirt. So that's a really cool, I mean, those, don't get me wrong, those tags are huge, but it's a really great indication of the scale of this vehicle, being able to see something much more human size right next to the boosters there, which are enormous. I mean, these boosters are the definition of bang for your buck because they are huge. And they just produce so much thrust. It is, the amount of thrust these things produce is just incomprehensible.
Absolutely. It also gives you a bit of an indicator of what the weather's like there today. I know Sawyer's trying to keep himself warm there on the ground over at the visitor complex at KSC. Hopefully, he's going to be getting himself a new SLS assembly hoodie very soon to keep him warm.
Indeed. And you can see there probably for one of the final times just on the left, the mobile launcher for SLS Block 1B, but we are now going to be focusing on seeing the front end, or I'm not sure if front end is the correct term, but the side of SLS with all the pretty stickers on, which is what we want to see. And we'll be seeing that shortly as it rolls past our cameras here, because of course there are some new emblems on the solid rocket boosters this time around, Alice, because a certain country is celebrating an important anniversary.
No, it kind of feels a bit wrong having you and I with our British accents talking about this, but I might add as a caveat, I am American. Yes, it's 250 years this year that the US is celebrating, and what a great way to celebrate it by returning humans to the moon. So they have got the 250th logos attached to the SLS for this mission. What an amazing way to celebrate the 250th anniversary of the United States of America.
Indeed. And we can also see the NASA worm. We've got the NASA meatball on the side of the service module. We've also, of course, got the ESA logo there because they built the service module. And we, of course, got a various selection of American flags dotted all over the vehicle, as you would expect and as is appropriate, which is wonderful to see. And we can just start to make those out as SLS rolls past our cameras at the press site. And it's also wonderful to see all the various umbilicals hooked up. We can see the tail service mast umbilical at the bottom with those two little platforms. Again, I keep saying little. They're not little, they're huge, but in comparison to the rest of the vehicle, they're relatively smaller. And we can also see the umbilicals up on the core stage and the second stage and the Orion spacecraft, of course, as well. All hooked up to receive power and commodities and fuel, etc. Of course, we're not expecting any fuel to be loaded just yet. That will be happening at the launch pad, but it's great to see everything hooked up in preparation for that.
Yeah, definitely not little. This vehicle is the size of a 33-story building. It just doesn't seem it because it's next to that enormous vehicle assembly building. But it is huge, and this is quite an amazing thing to see it moving on the crawler, which is, again, the size of a baseball field. It's a massive, massive thing to move this vehicle, the 4.25 miles to the launch pad.
Indeed. And it is getting closer. The anticipation is rising. We'll be getting some, we've got a wonderful, I think this might be Jerry in the field, and he's got in a very nice prime location right up by the road here. So, I mean, this is as close as you're going to get, boys and girls. This is pretty impressive. And you can also see there in the bottom left the various firing rooms of the Launch Control Center. So I'm sure there's plenty of NASA teams inside there right now monitoring this operation as well, just as they have done previously on Artemis I. But SLS is getting closer and closer. And you can see those huge crawler tracks very slowly and very gracefully just kind of plodding their way along the crawlerway as they approach 39B. Very slowly and very carefully. We have a question here from LSR, and they're asking, would there be any people inside the tower going along for a ride, keeping an eye that things are nominal? Well, Alice, we did see some people up by the crew access arm earlier, so there are people. I mean, of course, there's people in the crawler because you need somebody to drive the crawler, but there are people on board.
Yeah, I've seen them not only where the arm was earlier, where they were making sure that that retraction was able to go through successfully. I've seen them on the lower level as well, just making sure that they're keeping an eye on things, making sure everything's working the way it's supposed to be. I'm not sure how many are on there at the moment. Maybe Sawyer's got a better idea from the ground, but I would guess they've probably got a small crew on board as well as those that are managing the vehicle itself.
Yeah, I believe Sawyer is currently relocating for that press event with the NASA administrator and the Artemis II crew, which is about 10 minutes away. So we will be bringing that to you as soon as it starts, and it's going to be very exciting to actually hear from not only the newly appointed boss of NASA, but also the people who will actually be flying on board this rocket. We'll be able to speak with them, which is going to be very exciting, and it's going to be really cool to hear from them hear from the people who are actually going to be strapping themselves to God knows how many millions, whatever unit you want to use of thrust that is going to be produced by this rocket, hopefully as soon as February 6th or 7th,
Yeah, you
when
can see
that
it
launch
moving
window
there as well,
opens.
Ryan. And what a great location that they're going to be holding this presser. For those that don't know the site very well, just to the right of where we're looking at now, to the south of it, is that press area, which is where the countdown clock is. So they're going to be positioned right in front of where we see the crawler right now. It'll be moving in the background as they're talking about this mission. And I think NASA's done a really good job of really thinking that through and making sure that people visually see the SLS on the move. We're going to the moon. This is the lunar vehicle that we're going to be using, and this is the crew that's going to be on board.
Yeah, if it wasn't a press event, which with questions being asked by the media, then I think they should have hosted it on board the mobile launcher. I think that would have been cool, but I think it's quite difficult to host the world's media on board the mobile launcher so they can ask their questions.
Also, possibly a little bit loud. I don't think we kind of really covered that, but this is a huge vehicle. It weighs an awful lot of weight, a lot of pounds. I'm sure it's causing a lot of sound on board, both the mobile launcher and around it. We obviously can't hear it from where we are. I don't know, again, if the crew's on the ground, when we have moved and come back to us, they can let us know just how noisy it is to be moving that kind of weight around.
I'm pretty sure I'm sure someone in chat will correct me if I'm wrong, but I'm pretty sure each of those kind of is feet the right word of the crawler? I think they have 2 generators each. So if you think there's 4 feet and there's 2 generators, there's 8 generators running in the crawler just to move this thing at under 1 mile per hour. There is an incredible amount of power being produced by that crawler to get this huge mega moon rocket on its way to the launch pad. And I believe we can see some banners strapped to the side of the mobile launcher. We've got the US flag and the Artemis banner, like we saw last time around, which is awesome to see on the mobile launcher. And we were getting a little bit of an 39B eclipse here, because you can see SLS in the foreground and 39B in the background. And that, of course, is the launch pad this rocket will be launching from. And that is really, really cool.
Very cool. And I'm sure, unfortunately, it looks like we've got all that cloud. It's making it a little bit difficult to see it as clearly as we normally do on those gorgeous blue days out at Kennedy Space Center. But yeah, we can just about see those arms in the background where you're going to see 39B, which is where it's heading. At 4.25 miles from the vehicle assembly building out to the launch pad over the next 12 hours. And I might caveat, we are not going to be live for that entire time, right, Ryan?
Yep. Unfortunately, we will not be talking for 12 hours straight. I mean, very fortunately, in my opinion. But we will have live views on Space Coast Live 24/7. Of course, that runs 24/7, as is in the name. And I'm pretty sure, to the best of our ability, we will be keeping a camera trained on SLS to monitor not only the remaining rollout operations, but there is a lot of pre-flight testing that is going to be taking place at that launch pad. As Philip was talking about earlier, we're going to have swing tests of the crew access arm, which is, of course, something extremely important to test out. We are going to have the vehicle and the launcher being hooked up to all of the commodity lines. We will see some validation of all of those commodity lines. The vehicle and the tower will be getting powered up. For example, you can already see it's got some power because it's got those blinking lights warning aircraft, such as the NASA helicopter, that it is indeed in the area. And yeah, after that, we'll see the wet dress rehearsal. And hopefully, fingers crossed, if all goes well, we will see the launch after that.
We're optimistically. Oh, I can't even speak this morning. This is a problem when it's an early morning, right? Yeah. We are optimistic about it all, but realistic when it comes to the many stages that we still have to pass. This is an incredible sight to see this on the move. It does signal that they are very confident that they are ready to be able to launch the SLS, but there is still a lot of things that they need to get through before we get to that launch date, which could possibly be as early as February the 6th, but we also have some backups in March and April as well.
We have a little bit of support here from Finola. Thank you for becoming a Red Team member. And we have got a huge, and I mean this, we have got such a long queue of questions. So first of all, thank you for all of the questions. But we are very quickly approaching the crew conference, which will be in about 5 minutes' time. So very briefly, we have got one question here from Bideford, and they are asking, Ryan, do you know why they are spraying water on the treads? Well, they're not actually spraying water on the crawler rather, itself. They're actually spraying water on the crawler way. And as Sawyer was talking about earlier, these are huge trenches essentially made up of river rock, which is, really great at being able to support the immense loads of this rocket. And the reason they spray the water on is to essentially try and stop dust and stop anything sparky or anything bad like that happening. So it's essentially just to kind of, for lack of a better word, it's to calm the rocks down before they get compressed by the immense weight of the crawler and the mobile launcher, the tower, and of course the SLS rocket, because it might not have any fuel on board, but it's still a pretty heavy vehicle. No shame on SLS. It's still a pretty heavy vehicle. So the Alabama River Rock, which is used for the crawler way, it takes up a lot of weight, and it's a pretty impressive material to be able to do that.
Absolutely. I just saw the NASA administrator has gone to X this morning and shared NASA Artemis, nice and slow team. You break it, you buy it. I think that answers the question that we were asked earlier about why they moved that crew arm swinging it away. So we don't want to be breaking anything at this point. Nice and slow, nice and steady.
Yeah, not only would it take a few years to build a new rocket, it would also cost a few $1 billion. I'm not sure if I would want to be picking up the bill for a $4.4 billion launch vehicle, but that's just my opinion. My personal finances would not allow for that at the moment. Would be a lot of money to buy a new SLS.
Can you imagine? Oh my goodness.
And we're still seeing, I think people are still arriving to watch this rollout in person, which is awesome.
You want to address some more of those questions that came in the chat while we're waiting for the press conference to be set up?
Yeah, very quickly, we have a question here from, which one should we go for? Let's go for this one from Vsauce 314, and they're asking, why don't they recover the solid rocket boosters and the center? I assume you mean the core stage there in the middle. Well, Alice, like Philip was talking about earlier, first of all, that core stage goes a very long way. It splatters down in the Pacific Ocean. And, well, this vehicle just wasn't designed to be reusable.
No, it actually costs a lot of money and will require a lot more testing to make it reusable. And I know that sounds like a really silly thing to say out loud when we're looking at Starship doing that, but they haven't figured it out yet. When you're talking about a vehicle of this scale, it would have slowed down the process that much more. I think they did the right thing by not making it reusable at this point. Whether or not they're able to then adapt it in the future is another matter, or hopefully we can use a Starship or a New Glenn or whoever it is that we end up using in the future for this sort of launch that will be more reusable.
Yeah, and, this rocket also isn't the newest of rockets. The entire point of SLS really was to try and reuse that shuttle hardware, which is what the politicians in Congress really wanted NASA to do, to make sure that all of their centers and contractors and constituents were happy. So for better or for worse, a lot of the components of this rocket were kind of designed by the Senate. And the space shuttle, it was called a reusable launch vehicle, but at the end of the day, it was a bit more of a refurbishable launch vehicle when it got to things, and it was a very expensive launch vehicle to operate. And so is SLS, for good measure. It's a very expensive launch vehicle to operate. So yeah, it was designed a long while ago, and it's taken a long time to get to the pad and get to the point where it can fly crew. But regardless, this is the only rocket in the world which is, one, operational, and two, capable of carrying crew to the moon. It is proven it can do that with Orion on Artemis I. Now it just needs to put people on board and prove that it can actually do it with a payload. And that is what we are all so excited to see. And that crawler is getting ever closer to our camera on the ground. And that is very exciting to see. You can also see the actual security forces. Sometimes we joke that the Kennedy Space Center security are the alligators, but there are actual police and actual security out in full force to make sure that nobody does anything silly and keep SLS safe as it rolls by our cameras here.
I was wondering about the gators. Last time I was there for a crew launch was Crew 9, and there were plenty in the water when I was watching that take off. Certainly gave me a bit of a pause for caution.
Yeah, they do patrol the waters and make sure that everybody is behaving. And it's wonderful to see. Of course, Merritt Island is a huge wildlife refuge because, well, you need a lot of space for rockets. You don't want people building houses right next to the rockets. So it's a big wildlife refuge to provide some buffer between the people and population center of Titusville and the actual Space Coast itself. And I believe on the left-hand side, we are getting ready for that press conference with that crew and the NASA administrator. So at this point, I would say we can probably tune in to that press conference and see what these guys have to say. Pretty awesome intro sequence, if you ask me. There you go, 8.3 million pounds of thrust. That's a lot of thrust. I don't know what that is in metric. It doesn't matter. It's a big number. I can't comprehend it no matter what unit we use. That's how much thrust they're going to be launching on. So yeah, we will tune in now for that press conference with the crew of Artemis II and newly appointed NASA Administrator Jared Isaacman.
Of NASA's Artemis II rocket. We are slowly but surely rolling out to the launch pad. Good morning, and thank you for coming out here today to witness this monumental step ahead of our return to the moon. This morning, as that happens, I am joined here by the Artemis II crew, NASA astronauts Commander Reed Weissman, pilot Victor Glover, and mission specialist Christina Cook, and CSA astronaut mission specialist Jeremy Hansen, as well as NASA Administrator Jared Isaacman. With that, NASA Administrator Jared Isaacman.
Thank you. Good morning, everyone. Thank you for coming out to witness this historic moment. Before I turn it over to the real stars of the show here, the Artemis II crew, I thought I'd take a moment to just share a little bit about the journey that we're on right now and President Trump's vision for American leadership in space. Now, this all began call it just about 9 years ago. President Trump established the Artemis program, committed America to returning to the moon. Now, none of this should be a surprise. This is the president who created the Space Force. This is also the president that oversaw, during the last year of his term, the return of American spaceflight capability here to Kennedy Space Center after nearly 10 years from when the shuttle was retired. Now, I can tell you, we're off to a little bit of a slow start here. We've got about 12 hours to go approximately before the Artemis II vehicle will make its way over to launch pad 39B. Now from there, things will start to pick up the pace a little bit. So we'll have technicians put it through its motions. We'll ultimately get to wet dress, and then from there, this vehicle, along with about 8.8 million pounds of thrust, is going to accelerate the Artemis II crew here to near Earth escape velocities, so just under 25,000 miles per hour, farther into space than we've ever sent humans before, around the moon, back here safely to Earth. Now this is the start of a very long journey. Now we ended our last human exploration of the moon in Apollo 17, the 17th mission. Now I hope someday my kids are going to be watching, maybe decades into the future, the Artemis 100 mission. Now, we're talking about a lot of repeated missions, humans and crew members and cargo going to and from the lunar environment. Now, the architecture you see behind us here with SLS and the Orion spacecraft is just the beginning. Now, over time, launching missions like this, we are going to learn a lot. And the vehicle architecture will change. And as it changes, we should be able to undertake repeatable, affordable missions to and from the moon. And in that same vein, just as we begin, the cost to undertake a mission like we're going to undertake with Artemis II is not inexpensive. But where it'll go as we learn and gradually incorporate reusability is what's going to enable missions like Artemis 100 and beyond, right? And why are we doing this? We are doing this to fulfill a promise to the American people that we will return to the moon, a promise to all of the pioneers, the engineers, the scientists, the astronauts, the researchers from the 1960s, of which laid the foundation that we are standing upon right now. We'll do it inevitably to figure out the orbital and lunar economy, for all of the science and discovery possibilities that are out there, to inspire my kids, your kids, kids all around the world to want to grow up and contribute to this unbelievable endeavor that we're on right now. And before I hand it over to Commander Wiseman on this, I just want to acknowledge the contributions from literally the army that we have at NASA that shows up to work every single day to try and change the world. We don't do it alone. We have commercial partners, we have international partners that are involved in this, but we have thousands of people that have brought us to this moment. The thousands of people that have been working near 24/7 preparing us for this rollout, the thousands of people across the country that trained and prepared this crew to undertake this mission, the controllers that'll look out for them on space, the recovery crews that'll bring them safely home to their family at the conclusion of their 10-day journey. So with that, ladies and gentlemen, this is your NASA. Commander.
Thanks, Jared. Appreciate that. You said we're off to a slow start, but I heard Ike's going to go over there after this and drive, so we'll pick it up. The relative motion looks good, though. What a great day to be here. On behalf of myself, Victor, Christina, Jeremy, Administrator Isaacman, thanks for having us out here. And this is a great way to start rollout morning at Kennedy Space Center. I just want to build on what you just said about these teams. We see this beautiful hardware behind us, the SLS, the Orion. But for this crew, we've been on this journey for about 2.5 years, and we truly look at that and see teamwork. We see global cooperation. We see a strong nation leading the way. You look at those white boosters on the side. We've been out in Utah. We've met the men and women that are assembling them, that put them on rail cars and send them down here to the Cape. The core stage in the center, built by Boeing. Jeremy and I were there at Michoud when that thing got loaded on the barge and shipped down here with the RS-25s, tested at Stennis, assembled to the bottom of that rocket. The interim cryogenic propulsion stage, we met that whole flight control team out in Denver with United Launch Alliance. Building up into the European service module, we were in Bremen, Germany, meeting the Airbus team that has assembled that, and the European Space Agency, and then up to our Lockheed Orion. We spent so many countless hours in that vehicle preparing. And then you look just to the left here at launch control, it's almost eclipsed, well, it is eclipsed by the VAB. Charlie Blackwell-Thompson leading her team and the exploration ground systems folks, that they have hit every single milestone for the last year to get to where we are today. They've hit every single one of them. It is awe-inspiring. And then back in Houston with our flight control team, led by Jeff Radigan and our launch directors, we really are ready to go. We were in a sim for about 10 hours yesterday, doing our basically final capstone entry and landing sim. We got in T-38s last night, and we flew here to the Cape to be here for this monumentous occasion. With that, I just really want to say thank you to all the press that are out here getting our message out. It's very important. And hand it back to Bethany. Thank you.
And with that, we will open the floor to questions. There is a mic over here on the left, and we ask that you limit to one question each so that we can get to as many people and questions as possible.
Hi, Marcia Dunn, Associated Press for Mr. Isaacman. What's your take on how realistic it is that Artemis II will take off in February? And if I might really ask Reed a real quick question, I loved your crescent moon shot recently. What's it like to go outside at night and look at the moon now?
So I guess take the first part of the question. I mean, we're continuing on with our Artemis II preparation campaign. I think we've held schedule pretty well, getting to roll out today. So we'll get out there. We'll put it through its motions. We'll get through wet dress. We have, I think, zero intention of communicating an actual launch date until we get through wet dress. But look, I mean, that's our first window, and if everything is tracking accordingly, I know the teams are prepared. I know this crew is prepared. We'll take it.
We like that answer. Going out and looking at the moon at night, I'll hand this all down the line. I'll be brief, but I think one of the most magical things for me in this experience is when I looked out a few mornings ago, there was a beautiful crescent in the morning sunrise, and I truly just see the far side. So that's it was a waning crescent here, so it's a waxing gibbous on the far side, and you just think about all the landmarks we've been studying on that far side and how amazing that will look, and seeing Earthrise, those sorts of things, just flipping the moon over and seeing it from the other perspective is what I think when I look out right now. Mike?
Yeah, thank you for that question. It is definitely different now. But it's also kind of like asking a kid how they feel about their homework. You know, it's a part of what we've been studying and training for. And I go outside, and now I think of it in a very different sense, that there's some scientific value in what we say about what we see. And we had a sim months back where when we walked out in the parking lot, Christina and I were standing there, and I had this overwhelming feeling that, like, wow, what science about the moon does in the future is going to at least be affected a little bit by what we say about that view. And so that has changed how I look at the moon since. And my dad asked me when we got a sign, do I see it differently? And I didn't right away, but I definitely do now because of that great team that we have getting us ready to do science. Nana?
I think for me, what I see is the fact that all the people here on Earth, when they look up at the moon during our mission, before our mission, after our mission, during Artemis III and missions beyond, all the way to Artemis 100, they'll know that not only have we been there in the past, but we actively go there. We send people there because we're humans that must explore.
Something I'll share with you. It was kind of neat. Over the New Year's time period, had a little time off, had my kids back at home from university, and we just had the best viewing weather in Houston for the moon, and it was approaching a full moon, and I had the kids out there, some mandatory science, observing the moon with me, teaching them landmarks that we've been memorizing as a crew, but they were lit up about it too, and that was just really fun. And I think the moon is something I've sort of taken for granted. I've looked at it my whole life, but then you just kind of glance at it, glance away, but now I've been staring at it a lot more, and I think others are going to join us in staring at the moon a lot more as there are humans flying around the far side. I think that's just good for humanity.
And with that, we'll take the next question.
Hi, thank you so much. TJ Mascaro with the Epoch Times. This question is for Victor and Jared. Looking ahead to missions like Artemis 100 and just the future of our space activities, a lot of talk seems to be around automation and computer pilots and all of that. I was wondering how important it is that we continue to build on manual flying in space, and what place will that have going forward?
It's interesting. First of all, did you target me because I'm a little bit of a Luddite, and I love, the inceptors or the controls that I can, put my hands on if I'm going to fly something. But I think what the last 5 years has taught me since flying the SpaceX Dragon, the same one that Jared flew, is that the tool needs to be designed for the task. And so I could, go on and on about this, but I think it is something that we have to think more about because the state of technology is where it is, and we're not going to undo all of that. And so finding ways to integrate software, hardware, but the thing that hasn't changed, as far back as we can read the record, we are still the same stuff. And I've been reading these, there's a journal that test pilots put together, and the Mercury and Gemini and Apollo astronauts used to go and give these presentations. And I've been reading their reports, and they say the same things that we say, that, having a window is important, having the ability to do critical functions is important. And just how we implement that, though, is going to change with the state of technology. Thank you for the question.
We're just talking about an evolution in terms of what, what are truly the manual inputs, right? So I would say probably the T-38s you're flying are maybe some of the last, aircraft you've touched that actually, when you put a control input in, you're actually directly moving a flight control surface. A lot of the fourth and fifth generation aircraft that are flown today, it's all fly-by-wire. So you're telling the airplane what you'd like to do, and then the computer's interpreting it and saying, this is what I'll give you. And I think you're going to just naturally see that evolution in spacecraft, right? We're not taking the human out of the loop, right? There can be some pre-planned waypoints as we navigate around the moon, and then perhaps a human is directly inputting this is the actual target location I would like to land at for some reason. The computer's taking that manual input and saying, now I'll put you there, right? And I think that's probably the evolution we're looking at. But no doubt, look, as we as we get farther into deep space exploration, the ability to rely on autonomous capabilities within the spacecraft become more and more important. And I'd say the moon is going to be a perfect proving ground for that, right? So we talk about building a moon base. Now, day one of the moon base is not going to look like this, glass enclosed dome city that we might imagine someday. That's certainly what the ideal end state would be, but it's probably a lot of rovers that are moving around, a lot of autonomous rovers that are experimenting with mining or some mineral extraction capabilities to start, printing with regoliths. So naturally, I think in terms of what we want to achieve in space, you're going to incorporate more autonomy in our robotic missions. We're looking at a mission to Venus right now that could have some onboard AI capabilities in it. So this is the way we're going to go. But I'll tell you, if humans are on a spacecraft, they'll always have a vote. They'll always have a say in it. How that may look today could be very much like the F-22 versus the T-38 of the past, if that makes sense.
And with that, we will take the next question.
Hi, thanks for doing this. I'm Ken Kramer, Space Up Close. Good luck and best wishes to Crew 11. I'm a pharmaceutical researcher, so I want to ask you about the science you're going to be doing. Tell us a little bit, one or all of you, how it's going to benefit Earth and also how it's going to benefit us getting to Mars. Thank you.
Go ahead.
I think that's a great question. One of the reasons that these missions are so important is the discovery and the knowledge that we bring back to Earth, and that is the entire point. We have both lunar geology science and we have human research on this mission. Human research is that we're participating in, everything from how we can top perform, behavioral health, immune response in space, which is a fascinating physiological response that humans have to microgravity. And there's a really neat new type of technology we're flying, an experiment called Avatar, where we're actually using chip, organ on a chip technology, cell on a chip technology to mimic how our cells, our bone marrow cells, will respond to microgravity in the radiation environment, to bring that science back to Earth, to understand how we can more efficiently send humans deeper into space and how we respond. So it's really exciting. We're happy to be a part of all that science. And talking about the lunar geology aspects a little bit, the moon is like a witness plate for everything that's actually happened to Earth, but has since been erased by our weathering processes and our tectonic processes and our other geologic processes. We can actually learn more about solar system formation, more about how planets form maybe around other stars, more about the likelihood of life out there, starting with studying the moon. And I think that's something that question is, in my opinion, one of the biggest philosophical questions of our time. And I think some of the first steps to answering it start with this mission.
With that, we'll take the next question.
Good morning. Jeff Faust of Space News. Question for the administrator. As we're preparing to go around the moon with Artemis II, I wonder if you can give us some thoughts on your plans for ensuring Artemis III can land humans on the moon by 2028. I know you've met recently with SpaceX and Blue Origin about speeding up the lunar lander development, but what should we be looking for in the months to come in terms of getting Artemis III, keeping it on schedule, or at least ensuring a landing by 2028?
Yeah, it's a really good question. So one, we will just continue to be, as transparent as we can as we make progress towards the Artemis III mission. The way the public can best follow on and probably measure progress is just observing launch rate. I mean, that is absolutely the key to, unlocking the capability that'll be necessary to bring our lander to the lunar environment and bring astronauts down to the surface. So. I will say I did meet with both Blue Origin and SpaceX on their acceleration plans. These are both very good plans. I would say they both reduce technical risk from where we were before, so that's good. But in the end, it's going to come down to launching vehicles very frequently to learn. Learn about prop transfer for sure, but you're going to need reusability in order to do that. So I'd say we're all, if we're on track, we should be watching an awful lot of New Glenn's and Starships launch in the years ahead.
And we'll take the next question.
Good morning. Irene Klotz with Aviation Week in Space Technology. Sorry for the sun. For Jared, you've ridden a couple of rockets, you've seen launches, and you've seen Starship up close and roll out. could you tell us what you think is special about this rocket, and if your opinion has deepened or enriched in the month that you've been administrator?
Well, I appreciate the question. We need more questions for the crew over here, because they're the ones about to embark on a pretty extraordinary journey on that vehicle. I would say I mean not a whole lot has changed from my perspective, other than getting I guess a lot of firsthand account of the people that and the effort that goes into building a vehicle such as this. And even more of the history that led up to this. Even just walking inside the VAB, which I've seen it I don't know how many times from the exterior, and then you go inside, you couldn't even find the SLS in there if you wanted to. I mean, and then that just brings back, what it must have been like during the 1960s when you had multiple Apollo vehicles in there, or at a time when or multiple Saturn vehicles in there, at a time when you had multiple shuttles in there. So I'm halfway through a roadshow around the country to every one of our centers, meeting the workforce, trying to hear from those that are actually doing the hard work that it takes to pull off a mission such as this. So nothing changed in my mind about the importance of the mission that is NASA, our path to achieving it, but I've definitely had an opportunity to meet a lot of the folks that are helping enable it, and it's just extraordinary. So thank you.
We'll take the next question now.
Hi, Elizabeth Howell from Space Q in Canada, and this question is for Jeremy. You've often talked about how Canada has been taking all of these steps in space for decades alongside our international partners, clearly including NASA here, and you've also said, let's imagine what's next for Canada. And so in your mind, what's next for Canada in space once we finish this step? Thank you.
Thanks, Elizabeth. I would just like to re-echo some of those previous comments, because against the backdrop of that rocket rolling, it represents an extraordinary American workforce right there, watching that thing roll out. And like Reed was talking about, we've been around and we've met them and we appreciate them. And no matter what their future is, that's a workforce that is trained to do extraordinary things. And they'll be redirected as we adapt and continue to do extraordinary things. And that is the same story in Canada. I've really applauded the American space leadership, because they carved out space for Canada to hone some of our skills, to develop workforce in specific areas and to bring that knowledge. And the future for Canada kind of looks like where the international collaboration wants to go. We aren't leading that collaboration. NASA's leading that collaboration, inviting our participation. We have skill sets, and I know Canada will rise to the challenge, just like they did in the Artemis. When we were asked to join Artemis, we started to lean into developing new robotic systems for deep space. Even we're working on lunar surface stuff now. So we'll just bring that workforce to bear to meet joint collective objectives. And maybe I'll just end with, I'm actually pretty pumped to see that, because in just a few weeks you're going to see 4 humans fly around the moon, and if we're doing that now, imagine what we can do next. I'm pretty pumped to see that come to fruition.
We'll take the next question.
Hi, thanks for taking questions. Richard Tribou, Orlando Sentinel. This is for the astronauts, sorry, Administrator. Tuesday is the 96th birthday of Buzz Aldrin, and there's very few all men, who've flown around or to the moon. I think we are down to 5, and they're all over 90. So, one, I know many of you have found inspiration talking with them. I know General Stafford was hand in hand during Artemis I. So can you each tell me what the Apollo crew have been able to teach you about what you're going to face, and also if you want to teach you about what you're going to face, and also if you want to wish happy birthday to Buzz, feel free. Thanks.
Happy birthday, Buzz. I'll just share my General Stafford story, which was the day we all got assigned to this mission publicly. My phone rang that afternoon. I didn't have the number saved. It was a Florida number, and I was thinking it was a telemarketer. I was on my couch. I was getting ready to take a nap. It had been a long day with the media, and I almost hit the red hang-up button, but I just figured I would answer it. I answer it, And it was General Stafford. Reid, congratulations. We are so excited for you. And I think that's the way the Apollo crew has always been. They are so fired up that we are headed back to the moon. They are so fired up that we're going on to Mars. They just want to see humans as far away from Earth as possible, discovering the unknown, the near impossible, as the administrator keeps saying for NASA as our charter. So we really love that. I also want to say, we grew up in the shuttle era, and we grew up in the International Space Station era. And 3 of us have been up there, and Jared's been in low Earth orbit. He knows what that feels like. So we do feel like this is an Apollo legacy, but for the 4 of us here, we are standing on the shoulders of the International Space Station and the science, the research, the long duration exposure they have had and what we have learned up there.
You know, I mentioned how I'm reading these journal articles from the 60s about Gemini and Apollo and some of the engineering lessons and piloting lessons that they, fed into the system. But something that's also very interesting that you just kind of get between the technical data is the people that they were. And I do find a lot of inspiration in that, just understanding some of what their families were going through, what they were learning, or what they didn't know they were learning. As we look back, we have the benefit of hindsight. And so I've actually been very fortunate to become friends with Rusty Schweikert, and Rusty gave me a bag of wisdom, quotes from different cultures all over the world that I took to the space station. And I'm going to take that little bag of wisdom, but also in my heart and mind, the wisdom that we've learned from Charlie Duke and General Stafford and Dr. Schmidt on what it meant to them. And some of the story that hasn't even come out yet. We're still learning things from the Apollo era. And so it'll be nice to take the baton, run our best race, and then hopefully pass that baton on to the Artemis 100 crew.
I think what they've taught me goes beyond the technical tidbits and things of that nature. And the biggest thing I can talk about is camaraderie. They taught me camaraderie because I've had the privilege of interacting with them for actually over 25 years now through a scholarship foundation that they gave back to. And then more recently at NASA Remembrance events, which are kind of little reunions in a lot of ways for the Apollo astronauts. And seeing the way they interact with each other, seeing the way they tell stories and the way they still love each other and being around each other and what they went through together and how that bonded them has been really instrumental for me in appreciating every single day with my crew and with the larger teams. And I will never forget seeing Fred Hayes at one of these remembrance events, shaking his hand, and before I even said, "Hello, sir, great to see you," he goes, "I heard you're going to break our record." And at that moment, he brought me into that camaraderie. And I made a promise that I will carry that forward and keep everyone in that spirit of camaraderie and carry it through our mission as well.
Apollo, just inspirational. I was inspired by Apollo as a kid. I think that's how I ended up here. I saw a picture when I was a kid of a human standing on the moon. It was either Buzz or Neil. But it just changed my perspective on things. I turned my Trios into a spaceship. I started exploring space in my imagination, and here I am all those years later. But for our crew, one of the required readings for this mission was Carrying the Fire by Michael Collins. And he does a great job of putting the human perspective in what was accomplished during Apollo. And it was pretty extraordinary. You were talking about it, Administrator, earlier about what they accomplished during that time frame. And I think it's a good reminder for us. I mean, we're doing extraordinary things now, but we can create even greater things in the future. We should not accept this as status quo. We should always be striving for more. And something else you wrote recently, Administrator, that I think touched all of us was just the appreciation for, we want to fly safely in space, but we also have to be willing to take appropriate risk. That's what this is about. And when we were reading Carrying the Fire, this is the part that really got my attention. Michael Collins jumped on a spacewalk from one Gemini spacecraft to the Agena. That's extraordinary. That is truly extraordinary. And so that was a courageous example, but they also weren't cavalier. They were taking calculated risks. And I think it's a great example for us to remind ourselves, hey, we're going to go out there, we're going to take some appropriate risk, and we're going to accomplish some extraordinary things. We're going to have some failures, some setbacks along the way, and then we're going to pick ourselves back up and keep going.
We'll move to the next question.
Hi, Kristen Fisher with The Endless Void. It's so great to see all of you on such an exciting day. You 4 are about to fly farther into space than any humans have ever flown, and with that comes some inherent risk, like you were just talking about, Jeremy. And so my question is, we've heard a lot about your training, but how are you training your loved ones? How are you preparing your families in these final weeks as you get ready to leave them behind on Earth?
Trying to train them honestly and openly. That is the best thing you can do. We just had all of our families together about a week and a half ago at the astronaut quarantine facility at the Johnson Space Center. That was one of the cooler moments in all of our training, just sitting around with our families around a conference table, and NASA was briefing them on the mission. Fellow astronaut Randy Bresnick, who was our technical lead, came in and gave them an amazing overview of the mission profile and the Orion spacecraft. And then there are the more personal touch points. I went on a walk with my kids. I told them, here's where the will is, here's where the trust documents are, and if anything happens to me, here's what's going to happen to you. And that is a part of this life. I actually wish more people in everyday life talk to their families in that way, because you never know what the next day is going to bring. So it's just important to be as open and honest as you possibly can. And then the other neat thing that has happened amongst all of us is our kids know each other, spouses know each other, we all text each other. It has developed this foundation that I know, even though it's a 10-day mission, I just know who everyone is going to lean on to get through this together while we're up there. On launch day, we've got the easiest job. We really have the easiest job. We've trained for this, we know exactly what to do, and it will be good. It's our families that we think about the most on launch day.
You know, it is an interesting part of this journey. We have the entire resources of our agencies helping to get us ready, but we have to take the initiative to get our families ready. And we have a fantastic family support team, but we do have to take some initiative and lean in on that. And so those are tough talks, but you have to have those talks, or they can be tough. And you know, having the experience of doing this to get ready for the space station gives some neat experience, but also just something to compare and contrast with as well. And so we were having one of those tough conversations, and I mentioned to my family that, hey, you know, if I forgot to close the garage and we're all in Florida, I'll close it when I get back. You know, not 168 days later, but 10 or 11 days later. And so we you know, that is an important part, and thank you for bringing that up, because it is something that I think about a lot. And I am also really grateful that we have, I was actually just talking to Jared's family about when we were here to watch the Polaris launch. I was here to support a colleague and their family while they watched their loved one launch. That's my favorite role in this office. That is my most cherished, honored experience that we get to do with and for each other. And we have some folks that are going to be supporting us. Two of them are here, our backups, Jenny and Andre. And we have escorts that are assigned to each of our families. And I just wanted to give them a shout out. We've all got someone, an astronaut, that is going to be with our family members when they're watching launch, which can be this terrific and terrifying moment all at the same time. And so I'm just really grateful to that team that helps us to get ready.
I think for us, in addition to all that, it's two things. First of all, I love talking to my husband. He's been very acquisitive about the actual technical aspects of the mission. These guys know my husband. So, you know, we're talking about what are the big milestones? What are the risky parts? When can he sigh a sigh of relief? When does he need to be glued to the TV? And talking about some of those technical things, every once in a while we just get a question that comes out about the vehicle or how the mission's going to go. And then the second one is just a little more practical. I really have to make sure he knows that it's not like the International Space Station where we can just make a phone call. So he's not going to be able to call me and ask where something is in the house. He's going to have to find it. That's been a big one for us.
Pretty similar for my family. Over the holidays, though, we did watch some Artemis I launch video and entry video just to kind of point out a few things that can catch you off guard, like when the main engine's light. It does look like for a few seconds the rocket is blowing up, and then it launches. So letting them know about that. Also, the re-entry, what they can expect to see and maybe not see and not hear from us, and that's normal, and there's just a lot of different stuff there. And so during those times, to just be calm and patient and not make any assumptions. And then the other thing I told them, maybe this is good for all of you, is during the mission, you know, it's the first time we put humans on this rocket. And so we've done a lot of testing of these systems, but when we get to space, we will probably see signatures that look a little bit different from testing. Maybe not a lot different, but a little different. And then the team is going to do what the team does, and they are going to worst case scenario everything. And so if you hear any of it, it might sound really bad. It's probably not that bad. We're just going through what's the worst case scenario, what's the next worst failure. And that's probably going to be par for the course on a mission for the first time with humans on it.
Can I take a little license here and I want to just say something to you all. Thank you for being here and helping us share, all of this perspective and time with and gratitude with the world. But you all have a really unique role. And what Jeremy said just reminded me of this, how we talk about this is going to be based on how we think about this, what you believe. And this is a test mission. This is the first time. If we aren't pointing the thing right exactly at the spacecraft, we're not going to get that high definition downlink. And we could go, oh, darn. Or you could say, this is hard. And they're safe. And they're going to be back here in a few days. And so how we talk about those challenges, how you all talk about those challenges is going to affect how the world sees this. And what we're doing is we're swinging for the fence, trying to make the impossible possible. And so I would just encourage you to think about that as we all go on this journey together in a few weeks.
And with that, we'll take one last question.
Will Robinson Smith with Spaceflight Now. Thank you for the opportunity. You all had the chance to go down to the pad when the ML was there. You've had the chance to get up into the rocket when it was inside the VAB, but pretty soon you'll have the chance to go back to the pad with your rocket and spacecraft there. I know you are liking to stay, focused on the mission and preparation, but can you imagine for the rest of us that don't have that experience of what that day will be like, the first day you get to go out to the pad when your ticket to ride is there? Thank you.
I'm going to start with the simplest human element, which of course it's going to be amazing and all that, but I want to reflect back a month ago for our countdown demonstration test. We were in the vehicle assembly building. We were in Orion. Everything was fully powered. I was the first one to get in the seat. Ike gets into seat 2 next to me, and I was like, Ike, look, the dim button works on the display. And he's like, no way, because in our sims, that button doesn't work, and we can't dim the display at all. And I just want you all to remember, we are 4 human beings getting in this magnificent spacecraft, and sometimes the simplest things put a huge smile on our face.
That human piece, I actually try to keep a lot of that to myself. I think there's a time and a place for it, and so excitement, for example, is something I get asked about a lot, and I don't let that out often. I think it can become a distraction, or it's a long story. I won't share it with you now, but I can tell you this, having walked out to 39A and saw a Falcon with a Dragon sitting on top of it, there was I'd say 300 milliseconds where I thought, I'd just be embarrassed if I walked out of this and said, I'm not doing this, that's crazy. But then I stood there in awe that, wow, we're actually about to go fly that thing. And then when they got to 10, 9, it was like, oh no, we're going to fly it now. And so I actually look forward to that, even though I am focused. I'm glad you started with that. I am focused. I'm not excited. I'm focused, but I look forward to a moment like that with that beast.
As astronauts, one of the qualities that we talk about a lot is adaptability. This idea that, yes, you train and prepare for everything, but the most important thing is that you're ready to take on what you haven't prepared for. And so one of the things that these 12 years I've had in the astronaut corps has trained me to do is to not have expectations. So today is a day I trained myself not to expect. But looking over there, that's an amazing feeling. I think that on the day when we climb in, I always have heard this adage, and it turns out it's true. Astronauts are their calmest people on launch day. And I think we do that, it feels that way because we're just so ready to fulfill the mission that we came here to do, that we've trained to do. We are so ready to just give back that it gives us this intense feeling of calm and readiness. And I hope and try not to expect that I will feel that way.
Last time we walked across that pad for the countdown test that Reed was talking about, and you go up the first elevator and you're on the bottom of the launch pad and you walk by the bottom of the solids and the 4 RS-25s, and even in that moment, it wasn't fueled and it wasn't creaking and moaning and it didn't look super scary, but in that moment, one of the things that I felt was gratitude. And just like, I just see people when I look at that rocket. And people have poured their heart and soul into this vehicle, and it's truly extraordinary. And they're 24/7 here across the country, around the world. People are just pouring their hearts and soul into doing this because they're fired up and inspired by what we can accomplish. And so I know I feel a lot of things on that day, but there will be a fleeting moment at least of gratitude.
And we are actually going to take just one last question, and then we will wrap this up.
Yes, thank you. There we go. Thanks. sorry, a little short. Sawyer Rosenstein with NASASpaceflight.com. I know one of the key things about this mission is the human factor of things, and I know you each get just a little personal kit that you can bring with you. Is there something special or sentimental that each of you is bringing with you that you're kind of proud to say, I brought this to the moon and bring it back to Earth?
I have a blank piece of paper and a pencil, and I can't wait to write some thoughts on that. I don't know what to expect, and I don't want to go in with any preconceived notions, so I know exactly where that note card is, and I can't wait to jot some notes on it.
My Bible, and my Bible, if that didn't go on the microphone, and an heirloom for each of my daughters and my wife.
For me, it's handwritten notes from people that I love. The idea that I can hold in my hands way out there, or in my case in the past on the International Space Station, I can hold in my hands something that they held in their hands and drew on or wrote on. That is really special to me. So I hope to find some in my care package when I get there.
Some things that definitely represent the people that put me in this position. But one of the most meaningful things is the 4 moon pendants that I gifted my wife and 3 children, I guess 2 years ago now. And they wore them for a while. I collected them back this summer, and they're on that vehicle right now, rolling to the pad.
We will conclude today. Thank you so much for coming out and for your interest in NASA. And thank you to the administrator and the crew for taking the time to answer these questions. Just a reminder that we will have a follow-on press conference and media availability with the acting deputy director or deputy associate administrator of ESDMD at 10 a.m. at the KSC press site. Thank you.
Well, there you go. Sawyer Rosenstein working his magic to get the final question in there, talking to Reed Wiseman, Victor Glover, Christina Cook, Jeremy Hansen, and of course, newly appointed NASA Administrator Jared Isaacman, as we continue to watch the Space Launch System rocket for Artemis II roll along the crawlaway and make its way out to Launch Complex 39B in Florida. Now, I will be honest with everybody, we were planning to wrap things up a little while ago, but we have got so many great questions in the queue that we're going to stay live a little bit longer so we can work through them. So I will say it's your final opportunity. Just like Sawyer, if you want to get your question in, tag us in chat right now at NASASpaceflight or at NSF, and we will add it to the queue and run through them whilst we are still live. But very quickly, we got a little bit of support over the last 40 minutes or so whilst we were watching that awesome conference with the crew. NG Plane Spotters become a PadRat member. Thank you very much. Manover Street saying don't blink or you miss it. I think that would have to be a very long blink in order to miss that. And Aaron Quake gifting a Red Team membership. Thank you very much for that support. Well, first of all, Alice, I will ask you, what were your thoughts on that conference? I thought personally it was very wonderful to hear from the crew who are about to fly around the moon.
Yeah, it didn't disappoint, did it? We said before we went over to the conference, what a great opportunity to hold it in that position with the SLS in the background. And I think I was kind of slightly distracted most of the way through, wondering whether it was moving or what was going on behind them. I'm sure they were as well. There was some great questions in there, and a big shout out to Sawyer with that last one, which was really a great question for them.
Indeed. Okay, let's run through this question queue here because we have got so many good questions that it's difficult to skip any of them. First one, which one should we go for first? Let's go with this one from 98 Central, and they're asking, has this mobile launcher rolled out other vehicles of the past? And Alice, I believe it's been adapted, but it has carried many rockets in the past.
Absolutely. It's been used on and off for a long time now. And yeah, it has been moved around and adapted for its use. As we've been talking about all morning, there is now going to be a new generation of it that's going to take over from Artemis IV. So they've learned from what they've had for this last few uses of it, and now they're going to update it and have a new mobile launcher going out with the next generation.
And we had a brilliant question from, where is it? I've lost it. Here we go. Anna was asking, do we know the wind tolerance for an occasion such as this. And I've actually brought up the newly released Artemis II press kit because NASA actually has released so much technical information. Jared Isaacman said on Twitter that they were going to be releasing technical information. He wasn't lying. They've released so much information, and they even included the wind tolerances, or like the weather tolerances for the rollout. And essentially, these are the tolerances that they had today for rollout. So all of these were met, of course, because the rocket is rolling out. But essentially, they were not allowed to roll out to the launch pad if the lightning forecast was greater than 10% within 20 nautical miles of the launch area. They couldn't roll out if there was greater than a 5% chance of hail forecast in the launch area. They couldn't roll out if sustained wind was forecast to be greater than 40 knots or peak wind greater than 45 knots. And they couldn't roll out if the temperature was less than 40 degrees Fahrenheit or exceeds 95 degrees Fahrenheit at the launch area. And obviously they met all of those conditions because they're rolling out. So that's nice to see. Was a little bit windy, as we were talking about just over an hour ago, but they are well and truly on their way now at this point, as we can see. Almost looks like it's hovering across the tree line there, but I can assure you the crawler is just hidden away behind the wonderful greenery as SLS makes its way to 39B.
Ryan, I just looked up because I'm always like, what date did it all roll out? Mobile Launcher Platform 1, just so everyone knows, was actually for the Apollo program, and it started with Apollo 4, and it also did Apollo 8 and 11, and then it was used for 52 launches between 81 and 2009 for the shuttle program. So hopefully that answers the question that came in earlier.
Yep, in various forms, this is literally already sent people to the moon, which is pretty mind-boggling to think about, but it's really cool how NASA is able to continue using hardware throughout the decades, and you know it still does the job. Let's have a look
To see that,
through here.
as much as this gets a bit of a flack for not being a reusable vehicle, there is reuse in the program.
Yes, the ground support equipment has gone through a lot of reuse over the years. That is a great point. We have another question here from 98 Central. Does the crawler keep the tower level as it goes up the hill? And for those of you not aware, because of the water table in Florida, the flame trench at the launch pad isn't actually dug. They actually built up with concrete to make the flame trench. So that actually means there's a ramp up to the launch pad. And Alice, I believe the crawler does have those big hydraulic kind of jacks to level out the platform as they go up the hill, because you wouldn't want to accidentally tip
No.
the rocket over.
Absolutely not. Can you imagine that weight? If it starts to tip, it would fall. No, the idea is that it keeps it level the whole time. Whether that is precise level or not is another matter. But the launcher's height varies between 20 feet and 26 feet, varying on what it's moving on. So hopefully that answers that question for you.
Yeah, there's a little bit of margin in there, which is, of course, they make great use of that margin. It would be a little scary if they didn't have it, to be perfectly honest with you, considering how big the rocket is. We have another question. We have Caitlin. They're asking, how many miles total is the route? And it is just over 4.2 miles from High Bay 3 at the Vehicle Assembly Building, which is, of course, where it was constructed, all the way out to 39B. But it takes a little while to get there because of how slowly or how carefully, I should say, they crawl this rocket out to the pad.
Yes, Jared Isaacman did remind them all, take it slow, because if you break it, you've got to pay for it, which I loved. It has to be slow and steady. This does have a maximum speed of 1 mile per hour when it's fully loaded. We don't expect it to even reach the 1 mile per hour top speed today. So it's going to take up to about 12 hours in total for this movement to get out there, slow and steady, cautiously, and making sure that everything is in one piece.
Yeah, I'm pretty sure that the speed this thing crawls at wouldn't even register on the vast majority of, classic car speedometers, your average car speedometer on the dashboard, because of how slow it is going. It is literally crawling along at not really a snail's pace, but a comparatively slow pace. Let's have a look through here. We have uh, Heath, and they're asking, when is the launch escape system aborted? Alice, I'm not sure if you have the timeline pulled up or not. Do you know the exact
I
time when
don't.
that's going to be pulled up?
No, let
Okay,
me have a
let me
quick
get.
look for you.
Okay. I believe it is whilst they are still flying with the core stage. It's definitely after the SRB's jettison, but I remember yesterday the mission managers were talking about the various abort options they have because, of course, they have that huge abort tower on top of the rocket, but they also have various Orion thruster abort options they have when they are actually, at the end of their burn and in space. Because at one point, when you're almost in orbit, using a launch tower, like you can see right there, it would be a little bit over the top for an abort scenario. So it's actually safer to use just normal, kind of RCS thrusters or normal thrusters to conduct a abort in the. Of course, we hope they don't need to, but in the event that they do need to, that's what they would do.
Hmm. Yeah, I don't think I've got much to add to that. I think you were quite accurate with it. NASA.gov does have a launch escape subsystem pages you can go and read through further details.
And we have another question here from Ethan, and they're asking, how does the SLS Block 1 and Block 1B compare to the Saturn V? Well, off the top of my head, I believe the Saturn V was about 113 or 111 meters, and SLS Block 1 is about 90 meters. I can't remember how tall SLS Block 1B is, though, but they are... SLS might be slightly shorter, but they are still comparable vehicles, right? They're still, at the end of the day, they're all moon rockets, which is
Yes.
equally cool.
I actually think it's slightly taller and heavier. The Block 1 is taller and heavier, but slightly shorter than the Saturn V, and it does generate significantly more thrust. It's 8.8 million pounds compared to 7.5. I think you said 8.3 earlier when we were looking at the graphic, and I thought then, I'm sure it's more than that. Yeah, 8.8.
And I just did a cheeky Google search. It says Block 1B and Block 2 are going to be 111 meters, which is pretty much the height of the Saturn V. So they are, comparably similarly sized vehicles. But, those SRBs, I mean, they produce so much thrust. I cannot emphasize how much thrust those SRBs produce for the size that they are. And the fact that the fact is they just produce so much more thrust than the Saturn V could on the first stage with its 5 F1 engines, because solids are just, if you need lots of thrust and you need it relatively cheaply in terms of space, SRBs are the way to go. They have their drawbacks, but they also have some great benefits.
These are great questions, by the way.
Yeah, this is why I wanted to stay live, because there's so many great questions coming in the chat, and there are even more coming in right now, which I am filing away so we can ask.
Hey, look, we could just make it up as we go along, and you guys can correct us live. Even better.
Yeah. Okay, this is a great question. Speaking about the rollout, North Richards is asking, how far has the SLS traveled so far? Well, if we look in the top left corner, we can see our wonderful rollout clock, and that is at 2 hours and 52 minutes, so about 3 hours, let's say, just to round things up. And you can kind of see from our perspective on the left, we have a head-on view of the rocket, and that means that there is a little elbow in the crawlaway, and that means we have gone past that elbow, which you can see in this wonderful animation, and we are just beyond that point now. So you can see the route on the left-hand side, and we are about roughly 1 kilometer into the journey towards the pad, which is, what's that?
Crazy to think it's taken us 3 hours to get about 1 kilometer.
Yeah. That is, for our Imperial friends, about 0.6 miles. So we haven't even traveled a mile yet, and we've been going almost 3 hours. That is the speed that we are traveling at today with the rollout of this rocket. And there you go, about 12 hours to get all the way out to Complex 39B.
We
And if you
won't be
look
live
back,
talking, you and I, for those 12 hours, but there will be
no,
live coverage. Just want to
yeah,
caveat that.
we will be live on Space Coast Live with the camera views, but we will be ending the commentary coverage a little bit earlier than that. But we will be staying live for the time being. So do not go anywhere because we are going to be bringing you these views whilst we still have them alongside our wonderful robotic views, which are always live streaming from the press site, which you can watch anytime. Okay, let's see what more questions we have in the queue. Oh, this is a great kind of future-looking speculation question here from Luke. They're asking, when do you think we will see the first European on the moon?
Oh,
Alice, let's start with you. What do you think?
I believe it was Artemis 4. So I understand it's a German that's going to be part of the first European mission, and it was recently announced that it was possibly going to be Artemis 4, but let me double check. They haven't announced who it is yet, obviously for good reason. But
Yeah.
yes, they're looking at the Artemis 4 mission as being the first one to have a European with them. Great question.
Personally, I hope it's really soon. But yeah, I would just I'd just be cautious because there are, of course, many nations partnering on the Artemis program. Canada is one of them, as we can see on this mission with Jeremy Hansen. There is also Japan, which is a huge partner in Artemis. I believe they have essentially guaranteed a seat to the moon in return for working on lunar rovers. Because that is the automobile industry is a big thing in Japan, and alongside NASA's rovers that they are currently working on developing they've got like a kind of like a commercial lunar program, which they're currently working to establish.
Yeah. And they're doing a lot with Gateway as well, aren't they?
Yes, of course. They are also collaborating on that. I mean, it's a long history of collaboration because they've been operating a module on the space station for well over a decade at this point. So there are many countries involved. Everyone will get their moment to shine, but it just everyone will kind of have to negotiate who gets to go first. Canada has obviously done a great job at negotiating that for Artemis II, but I hope it's not going to be too long until we see more people getting the opportunity to walk on the moon. Because not only is it great for PR, it's also, I think it would be great for, morale and,
And
sometimes
inspiring
things are
the
a little
next
bit grim.
generation. Don't you think?
Exactly. Inspiration is so important.
I think it's always really key when you're thinking about the future. You've got to inspire that next generation of people that want to get involved in this program. And we saw that with the Apollo program. There's not many people that were around in 69 to 72 that say that they don't remember watching one of the lunar launches and watching them land on the moon and how that inspired their career going forward. They even mentioned it in that presser just recently. I remember looking up at the moon when I was younger. I've met the Apollo people. They are inspiring. So hopefully we're going to see a whole new generation of people that want to take us further and progress humanity beyond our spaceship Earth.
We have a question here from Kaysen. They are asking how many Artemis missions are planned. Well, we heard in that press conference just then, Jared Isaacman talking about Artemis 100.
100,
So
yeah.
I think it's safe to say if they get the funding and if there is the commitment, which of course we hope there is, there's going to be plenty of Artemis missions.
That's what it all comes down to, doesn't it? When people always say to me, why has it taken us so long to get back to the moon? My honest answer is always politics. If you don't have the political willpower to get behind funding a program that is very expensive like this, then you're not going to be able to go further. So I think as long as we still have the momentum and support for Artemis, there will be those missions going forward. And we were talking earlier, what was it up to Artemis 5 that's currently already got funding set up?
At least in terms of the current architecture, I think it's
Yeah.
difficult to say because, there's definitely funding for the space launch system for Artemis 5. So that is that is Congress basically saying, we'll give you this money, but only if you use it in the exact way that we want you to use this money. So that kind of locks NASA into a specific architecture. But there are definitely more cheaper, more affordable, more realistic commercial options coming online that Jared Isaacman has been talking about, like Starship,
Yeah.
we've got Falcon Heavy, we've got New Glenn, maybe even Vulcan. Not
Very
exactly
exciting.
a very futuristic option, but it is an option. So maybe he can get his fingers in there and try and convince the politicians to move to a more futuristic, reusable, affordable, cost-effective option. But there's
That'd be
also
nice.
another part of this. Once we establish this presence, they want to be able to create an economy, which means people will want to go there anyways, just for the sake of getting a profit.
Yeah.
So that would then mean taxpayers don't have to fund the missions to the moon, which would be even better.
You have to caveat all of this by saying they still haven't even got fiscal year 2026 set up yet here in the US. It did pass the Senate, so it's going forward towards the president's desk to hopefully sign into law, and we can actually get some funding for this fiscal year. But we are still on that moment right now, coming up to the end of January, where the continued resolution is about to expire. So hopefully we can get that sorted very quickly. Events like this hopefully do fall in towards the favor of NASA getting fully funded for this next year.
Yeah, hopefully that does pass before the deadline runs out, because that would be unfortunate to have to pause things just for a lack of funding. I believe that what do they call it? It's like a minibus document or something that's gone through.
Right,
Has got
yeah.
all of the funding for NASA in there. So fingers
But
crossed that
almost
gets
the same
signed off
amount.
quickly.
Yeah,
Yeah,
it's just a little bit. I mean, say just a little bit. It's about 400 million less than what they had in the last fiscal year. But with everything that's gone on, hopefully that will still keep the doors open and everything running as it should be.
yeah, much worse than it could have been. I'll put it. I think we can leave it at that. It could have been
Mhm.
much worse. Okay, let's have a look through here. We've got a little bit more support. We have John with the $10 super saying, who will win, a giant car truck snail or the SLS crawler? I think the crawler would still win compared to a snail, just because snails are,
Snail doesn't have a chance.
yeah, snails are much smaller. It might be small, but it's not that small. And we have Diamond Paint with Diamond Dave again with a $5 super. Thank you very much for your support. And they are asking, is this only a single pass of the moon, or will they enter lunar orbit and go around a time or two before returning? And Alice, as I believe you were saying earlier, this is just going to be a lunar flyby this time around,
Yes.
correct?
Yeah, we're not going into lunar orbit with this mission. We're actually going to go past it to a point about 7,500 kilometers past the lunar far side. So this isn't like the missions we've seen before. This isn't Apollo. This is us kind of doing a bit of a strange elliptical orbit around the lunar area, which does mean we are going further than ever before.
Yes, and regardless, it is going to be a spectacular view. So I am very much looking forward to all of the observational data that the crew are able to perform. There's a little trajectory animation for you there.
Nice.
I'm
I
also
like that.
I'm also looking forward to that 4K video. We're
Yeah.
not expecting to get that live, just simply because of the bandwidth restraints and restrictions.
We don't quite
you know.
have everything in place to be able to bounce the signal around that far side yet. But it will be interesting. It's the first time humans are going to be able to do this really for a very long time, to be able to see it from this angle. Since the 1972 was the last time we sent up a lunar module. It's quite amazing to have humans up there again.
Yeah, and I mean, it is an incredibly exclusive club of people who have actually seen the far side of the moon with their own eyes. Because, of course, it's
Have you
tightly
met
locked.
any? I've got to
I
ask.
have not. I have
I got
not.
to meet Charlie Duke a couple of years ago, and I was I don't often get starstruck, but certainly meeting him. And it's crazy to think that he was just a person doing his job as an astronaut, but what an amazing person he is, and what a great symbol of inspiration that we can look to these guys. And they were just saying in that presser, I think there's only about 5 men left from the Apollo program that are still alive who are able to share their stories. So it's great that they are here to be able to witness Artemis II and us returning to the moon.
Yeah, and just in case anyone is asking, why don't they install Starlink? Starlink orbits at about 500 kilometers, and the moon, the moon's a little bit further away than that. It's about anywhere between 360,000 kilometers to 405,000 kilometers away. So it's very difficult to get communications out to the moon. When they were doing the Apollo missions, the reason why they always landed, on the kind of the near side of the moon was so they had communications with Earth, because there's no relays, no satellite relays or anything like that at the time. So the only way they could communicate with Earth is when they could see Earth. And it's going to be a pretty similar story this time around with Artemis II.
We're getting there. They are building this, and hopefully soon we'll start to see more of these lunar data centers. I know that there's one up there at the moment that was in operation. We'll hopefully see more of those coming up in these commercial missions that are planned for later this year.
Yeah, and we're also seeing a relay satellite. I know that has been launched by China, so their moon ambitions. They're also working on creating lunar communication networks in order to get those things off the ground. And along those lines, we have Prajwal, who's asking, how close is the Chinese Space Agency to a manned lunar mission? That's a great question because
It
nobody
is.
really knows.
They say by 2030, which sounded so far-fetched, but now that's only 4 years away, which is crazy. And obviously they've done an incredible job over the last few decades of continuing lunar landing, robotically, obviously. So we're not sure is the answer to that one, I think, Ryan.
Yeah, there's a look, if they continue this pace and they keep cranking out rockets left, right, and center, and they keep building things at a pace that is literally, breakneck speed, then I don't have any. I wouldn't bet against them. I'll put it that way. But with the nature of that space program in particular, sometimes it's very difficult to actually get accurate or official information, and not things that have been reposted and regurgitated through various social media platforms 10 times, and then sometimes things can get the meaning of things can get confused and things like that.
These are great questions.
Yeah. Okay, let's have a look through here. We have a question from Brick Travi asking, couldn't they modify a Crew Dragon on a Falcon Heavy to transfer astronauts to the human landing system instead of the SLS? That's another great question.
I was going to say they could. Will they? I certainly SpaceX would like to see that, and I think a lot of people will support it. At the moment, the SLS is a known quantity, has been able to do a lot that we haven't been able to test yet with the systems that are available to us with the commercial entities. So I think time will tell. I think we are in a bit, like you've mentioned before, we're in a period now where we think this is probably going to last maybe up until Artemis 5. After that, it could be anybody's guess what's going to happen next with this program.
Yeah, and I mean, it depends how much you want to fiddle with the mission profile, because I think technically there's even the possibility of launching a Dragon on a Falcon 9, like normal, just to low Earth orbit, dock with a Starship, and then use the Starship, put the crew on board the Starship, and then fly the Starship to the moon. And then, so instead of doing the docking around the moon, you're doing the docking around Earth, and you're just using the Starship to fly to the moon, land on the moon, and then come back home to Earth orbit. But then, how far do you want to go? Because at some point, SpaceX wants a human rate Starship to be able to fly humans from Earth into space. So you might as well just do the whole thing on Starship. So it depends how far into the future you want to look, and how, there's so many. The great thing about the modern commercial space industry, and there are so many people with so many vehicles, there are so many different ways you could create a mission profile like this. And that's going to be really advantageous as you go into the future, because there are so many people working on this stuff. You have so many problem solvers, and you're just going to have so many options. You're going to have, imagine, even 10, 20 years ago, having, double digits of commercial launch providers online. It was unheard of. It was pure science fiction. But, very soon that is going to be reality.
Commercial competition is absolutely key to this. And that's why I think we get so excited when we see the likes of New Glenn coming on board and having successful flights. As much as everybody's been supporting SpaceX, we want to see the other competition coming on board, because it's just going to push us further and hopefully get us our ambitions that we want to reach to the moon and beyond.
Indeed.
So we are waiting for a presser, just so everyone's aware, and we'll keep going, I think, with questions until we get to that point.
Yeah, we heard at the last conference they said they were going to do another one inside the media building. It doesn't sound like we're going to get any video from there, unfortunately. But if I believe Sawyer is heading that way, there is a.
He's just said that it sounds like there is a chance to ask more technical questions since yesterday's ended early, so they're recording that right now. Hopefully we can get that
Wonderful.
out
So,
quickly afterwards.
yeah, so we will bring that to you after the fact. So it doesn't sound like we're going to get it live, unfortunately. But you may have seen yesterday there was a pre-rollout press conference with a lot of the mission managers and senior personnel at NASA, and they started 5 minutes late and then they ended 5 minutes early, meaning there was only about 20 minutes of Q&A, which was a little bit unfortunate. But thanks to getting the attention of the NASA administrator, I think I'll say, he has encouraged them to do another press conference today, so we have more opportunities to ask questions, which is, of course, a wonderful thing. We are very grateful for that opportunity to do that, because this is a very important mission and we have lots of important questions we want to ask, and there's no better way than literally asking the people who built and managed the rocket.
There are so many questions. People want to get into the technical weeds, but it's difficult, I'm sure, for those that have worked on it to be able to talk about a lot of things that are going on with the mission right now because they don't want to jinx it. I think that's possibly why it was cut short yesterday. I know that sounds like a really silly thing to say out loud, that they don't want to jinx the launch, but everything was so focused on getting this rollout today. I think that took up everyone's bandwidth yesterday. So hopefully now we're seeing the success. We've got a bit more time to really think about it. I just had a follow-up question from Charlie in the UK, who's just messaged me asking how close to the moon will the mission get to. And as I mentioned earlier, it's going to go around 7,500 kilometers from the lunar far side. So hopefully that answers your question, Charlie.
And we have another great question from Arturo Benevent, and they're asking, how many stages does the rocket have? So, always good to go back to basics. Alice, if you wouldn't mind walking through the various components we see here on our screen of the Space Launch System.
There's a lot of stages. I'm going to go and pull up the press kit because there's so many information on there. This is very different to what we're used to. We're very used to the Falcon 9 setup. This has got a very different setup completely because obviously the mission is that much longer. I'm pulling it up now. I believe there are 3 stages. Am I correct?
2.5, 3, kind of. It depends how you want to how you want to name it, because of course it has the side boosters with the solid rocket boosters. So depends how you want to classify that, really.
Yeah, I'm pulling it up here. If you look up at NASA.gov Artemis II press kit, it's got everything on there that you could possibly need to know and more some. So we are looking at a very different setup to what we're used to. Core stage, as we've mentioned before, will be burning much longer than what we're used to for the first stages that we normally see on like a Falcon 9. That's going to be doing, what would you say, about 8 minutes was it we were talking about earlier? We're expecting from the core. And then we will see the upper stages going through.
Yeah, we have that. Oh my goodness, I've forgotten the acronym. The ICPS. What's it called? It's the something cryogenic propulsion stage. This is so embarrassing. I've completely.
It's not embarrassing. We've been up since very early this morning. That's why I was like, oh, you've caught me off. I'm also getting messages from people at the same time asking questions, which is really lovely to see and hear. But paying attention to everything as it's going on is something else.
Google is going to be my friend because it is, of course, the interim cryogenic propulsion stage, named as such because it is the stage they are going to be using before the brand new exploration upper stage is ready. That is a brand new stage being built by Boeing, which is going to be used for SLS Block 1B, which is the next variant, and SLS Block 2, which is the variant after that. And it's going to be a much more beefier stage. The ICPS technically is essentially the upper stage from the Delta IV and Delta IV Heavy rocket, built by United Launch Alliance, slightly modified to fit on SLS. So technically, if you really wanted to, you could call SLS the Delta V, although that would be incredibly cursed and you would be not very popular within the spaceflight community.
You guys are really pushing us with these questions. I love it.
Yeah. Okay, Ireland has become a PADRAT member, so thank you very much for that. The Point 23 is asking, why can SpaceX's Super Heavy move faster on its crawler, but SLS cannot? Well, I think it's really just a difference in the way that the operations work, because SLS, when it rolls out, it's on this huge crawler transporter, and they're rolling it with the launch platform, with the launch tower, with the platform, with, I already said the platform, with all of the infrastructure, literally being moved from the VAB to the launch pad. It's all mobile. But Starship, on the other hand, they only move the vehicles and then they actually assemble the vehicle at the launch pad. It's all static. They have a permanent tower with a permanent launch mount, with a permanent infrastructure to connect it all up. So I think the actual pure mass of the Starship Super Heavy Booster and Starship itself is so much lighter, to the degree that they don't have to be as careful. There's less stuff. There's less stuff to break, basically, I think would be the simplest way of putting it.
Yes, and they've mass-produced a lot of their components as well. So if anything does go wrong, they're able to replace them much quicker. If you've ever been out to Boca Chica, which I know you have, Ryan, it is a very different setup there than what you see at Kennedy Space Center with their VAB. Like you mentioned, you see stages around the site, and they moved very quickly around the whole area. So very different setup. Apples and oranges, as they say, when you're trying to compare the two.
Yeah, one of them you can literally, drive up to the launch pad on a public highway, and the other one is the Kennedy Space Center, with a little bit more security and restrictions and
better roads though at Kennedy Space Center. The road out to Star City or Starbase, my goodness, the potholes out there. Ooh. If you're driving out that way, make sure you've got a decent off-road vehicle.
It is eaten tires on more than one occasion. I think we can leave that there. Starship also rolls as individual stages, right? You've got to remember it rolls out the booster and the Starship separately. So they are, not only is it a smaller component being rolled out, but it's literally just the vehicles, and there's no fuel on board. It is true that there isn't any fuel on board the core stage or the upper stage of SLS, but those solid rocket boosters, they use solid propellant and they are cast, so they are fully fueled technically with their propellant. So that adds to the mass being rolled out to the pad.
I feel like it needs its own little musical theme tune, keep rolling, 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 rolling for the next 12 hours.
It would have to be a very long song to last that long.
It really would, wouldn't it?
Okay, we've got a couple more questions in here. First of all, let's ask this question from Zeno. And they're asking, do you think there is a chance that there will be another rocket, as in not SLS, ever to be built in the VAB or use the crawler transporter, or is this the end of an era? Alice, what do you think? Because I think we're definitely approaching the point where NASA might no longer want to build rockets in this sense and want to use commercial rockets, but they could also lease out the VAB and let other people use it.
Absolutely, exactly what I was thinking. That building was built back in the 60s for the Apollo era, Saturn V. It's going to be used because there isn't anything else comparable to it. And if you're wanting a safe space to be able to assemble a vehicle, then you really can't beat the VAB. And they're going to keep adapting the crawlers. It might not be in the same configuration that we're seeing today with the SLS, but I think we'll still continue to see the VAB and crawler in use in the years to come. I can't see them replacing it anytime soon. I wouldn't be surprised if you gave the offer to SpaceX or Blue Origin or ULA or others to be able to utilize this facility. I'm sure they would all jump at it.
I don't know if this is true, but I think there was a rumor a little while ago that potentially they wanted, or NASA was asking SpaceX if they wanted to do Starship stacking in there. Personally, I wasn't 100% sure how that would work, because on the crawler way to 39A, SpaceX has kind of built a hangar in the way, which would be difficult to relocate to build a Starship in the vehicle assembly building. And of course, SpaceX is working on their huge gigabay construction facility just down the road from here. But, never say never. There is always the potential that individual components could be assembled in there and not an entirely fully stacked rocket. So, yeah, never say never. And I sure hope that the facility sees use in the future, because it is an amazing facility that was kind of with, incredible forward thinking in the 1960s. They thought ahead. They didn't build it for the Saturn V. They built it for the next big thing. after the Saturn V, which we are still yet to see. We are yet to see a rocket launch out of Florida bigger and better than the Saturn V. So it would be great to see it get some use in the future.
Great question.
What's next? We have another question from Ethan, and they're asking, how does the exploration upper stage compare to the S4B? Great technical questions, and the internet is once again going to be my friend here.
I'm glad you
because-
asked the internet and not me.
Yeah, let's have a look through here, because the as I was talking about earlier, the exploration upper stage is the brand new upper stage being built by Boeing. It's currently under development. That's going to be launching on the SLS Block 1B and the SLS Block 2, if it will ever launch. Unfortunately, to put it that way, but being realistic. They're similar in the fact that they're both hydrolock stages, so they both use hydrogen for their fuel, and they use the oxygen, of course, for the oxidizer. The S4B, which is, of course, from the Saturn V, had a single J2 engine, which burnt for about 480 to 500 seconds, with about 1,000 kilonewtons or so of maximum thrust. The exploration upper stage, on the other hand, is going to use 4 engines. It's going to use 4 of the RL-10C3 with a burn time of 1,200 seconds, so significantly longer burn time. And it's going to have a maximum thrust of 433 kilonewtons, which is less, but it's got a much longer burn time. And, you know, thrust isn't incredibly important in space because you're not having to fight against Earth's gravity to the degree you are when you are, you know, leaving Earth from the launch pad. So slightly less of a concern for that specific use case.
I like to think you just had all that information just there at the top of your head, Ryan.
Oh,
100%.
100%.
Quite the wealth. Absolutely love that. But if you really want to know how to assemble an SLS, you know what we've got? We've got merch for that.
Oh, incredible segue. If you want to build an SLS at home, this is the shirt for you. You might need a big house. But there you go. We've got our new assembly instruction shirt and sweatshirt available at shop.nasaspaceflight.com. This launched today with the rollout of SLS for Artemis II. And it's got this wonderful, cute little diagram. Step 1, put your spacesuit on, and then you can build the rocket. You've got the stacking of the solid rocket boosters and the core stage. You can even see the individual fuel tanks inside of the rocket. How cool is that? And you can
I'm going to
also
wear
see
that when I go to Spacecom later this month so that everybody there who works for NASA knows exactly where this has come from.
Make sure to get some pictures as well, because we'll throw them in the store. And
I
you can
will
also
do that
see
for
the
you.
little, not animation, diagram of the flight path around the moon. The flyby for the Orion spacecraft, which is a wonderful little design, somewhat inspired, you may be able to see, by a international Swedish furniture company, which you can get at shop.nasaspaceflight.com.
Somehow they make more sense than a lot of the instructions that come from said furniture company.
It's a much simpler design, I'll put it that way.
Yes. Makes this whole thing look really easy, but as we've mentioned before, there's been thousands of people that have contributed to this program, not just recently, but with the legacy products as well from the shuttle era. So it's not quite as simple as what we put it down to. Or is it? Who knows?
This is one of, if not the most complex machines in the world. I'd say the Saturn V might be a little bit more complex just because they were doing that in an age before, you know, they're doing it in analog and not in digital. You know, the flight computer on board the Saturn V landed people on the moon with less memory than, you know, you can fit within probably a few nanometers nowadays. So it's really, really impressive what they were managing to do in the 1960s, you know.
Well, look, we're
But-
getting a bit of a capsule video at the moment for integrity.
Yep.
It's, of course, the Orion capsule that's going to be taking the 4-person crew on this Artemis II mission to the moon as soon as February the 6th. as early as, should I say. We're not sure at the moment. It really does depend on, well, we've been saying this all morning, and we try to be optimistic but cautious that there are a lot more stages that we have to pass through before we get that first flight with humans returning to the moon. But we are hopeful that it could be as early as February the 6th, with backup dates through February, March, and April already available.
Yeah, NASA is being really, really vocal that they are not going to set a specific launch date until they have gone through the testing, until they have tanked the vehicle, until they are confident that they are ready to fly, because they don't want to rush these things. They want to be slow and steady, and they want to make sure they make the correct decisions at the correct time to go ahead with the flight. So if anything is looking abnormal, it's always better to pause, hold, and reevaluate. And that's the same in the final countdown as well. NASA has a number of options to hold. As we saw on Artemis 1, they have a number of options to hold and recycle if they need to evaluate things. I mean, heck, even on Artemis 1, the launch attempt that actually flew, they sent the red team out to the pad to adjust some valves hours before launch with a fully fueled rocket. That's just mind-boggling. And it launched.
Yeah, it launched, and obviously they're going to be more cautious with this one. This has got to be carrying humans. This is a massive deal, and as we've seen in recent weeks with the medical evacuation from the ISS, NASA is always going to approach things when it comes to people involvement with an abundance of caution for good reason.
We have had a tip at tips.nasaspaceflight.com from Rocket Scientist 1 saying Godspeed Artemis 2, and that's a $50 tip, and that goes directly to us. Yeah, thank you very much for the tip, Rocket Scientist 1. That, of course, comes directly to NSF, cuts out the middleman, so to speak, and that goes directly into the pot, which helps to fund all of the equipment and all of the infrastructure that we have here. It's not easy, and it's not cheap operating tens of robotic cameras across the US, but contributions like that definitely make it easier. So thank you very much for your support. And yeah, Godspeed Artemis 2. We hope this flight is fully successful.
I think we're all waiting with bated breath for this. This has been a long time coming. I mean, it hasn't happened in my lifetime, and I'm not giving my age away too much, but I'm not that young. So to be able to see this is quite incredible to finally witness this.
We've got a few more questions, of course. Keep them coming at NASASpaceflight or at NSF. We are going through the question queue, doing our best to answer them.
We'll make up the answers depending on what you ask.
Yes. Okay, we have Luke, who's asking, are we expecting any live streams or similar from the crew during the mission? Now, Alice, as we were talking about, the moon's quite far away. So communications are going to be limited at times, but I believe when they have the opportunity to, they will be trying to broadcast back as much as they can.
Absolutely. That's the plan. Like you mentioned, it is a very difficult communication relay system. There are things that are able to help them with it, and hopefully they're going to be testing some new communications as well with the whole system that they're trying to deviate away from. I'm sure people are very aware of the legacy TDRS system that we've been using for years for low Earth orbit. We're looking to update that whole setup as we move forward to the moon and beyond. So I think we're going to be seeing a lot of lives from this. Hopefully we'll be able to see them across NASASpaceflight as well as on NASA TV. But what I really would love to see is that in the mainstream media, we get to see a lot of this as well, so that the masses really get to understand just how important this mission is to humanity.
Indeed, that is the wish. We want everybody to be excited and looking forward to the future. Of course, not everybody is going to be a Giga Spaceflight fan like you and me. Not everybody is going to want to tune into NSF as much as I would want them to. But, you know, being a little bit realistic, we might not capture the general public's audience here, but we want to be able to share
they might
this
nudge
with
us
as
in the
many
right
people
direction.
as possible. Yeah, exactly.
There's no reason why they can't see it on one media platform and then come and find us to be able to enjoy the NASA spaceflight, space nerdery, as we will call it, with the team here.
Exactly. Okay. Sodacan 56565 is asking, are these the bowl solid rocket boosters mounted to the sides of the rocket, or are they the old generation? For those of you who are watching, when was it? I think it was in the summer now, in Utah, in Promontory, Utah, we were live streaming the test of a new solid rocket booster called the bowl. I forgot what it stands for now, but it's essentially an evolution of the booster being produced by Northrop Grumman for the SLS Block 2. These are not that booster. These are the old style boosters. These are technically shuttle flight hardware boosters, which are being reused, quote unquote, recast with new solid propellant. So these are very similar to the shuttle boosters, but the shuttle boosters were actually 4 segments tall. So they had the 4 segments and then the nose cone on top. These ones are actually 5 segments, so they've made them a little bit taller, and that means they have a little bit more propellant to burn, so they can be a little bit more powerful than the shuttle ones. But they're literally shuttle hardware, which is being reused and repurposed for Artemis. Same with the engines on the first stage, I believe. Those are RS-25s, which are being reflown. And I think, I can't remember where I saw this now, but there was a document that came out. I believe there is one component on this rocket which flew on STS-1, the first flight of the space shuttle, all the way back in 1981. And yeah, it's a little bit of sweet. It's a little bit of sweet because, you know, that's a piece of hardware which flew the first historic mission of the space shuttle. But on the other hand, 40 plus years later, it's still finding use in an active spaceflight, which is
amazing. Cool. There's a lot for us 40-something-year-olds. I believe we've got some great footage at some point when we're ready for it, Ryan, for the rollout, for those who've missed the earlier footage that we covered.
Yeah, our social media team, as always, is out in full force, pulling all of the camera feeds, and we have a wonderful sped up time lapse here from LSR on our social media team of the rocket rolling out of the VAB this morning. So
love this.
if you
great video.
This will also be available, I'm sure, on our various social media platforms. So whichever one is your preferred platform of choice, there's a 90% chance we'll be on there. So make sure to go and follow us to see many, many time lapses like these, which are always being posted from our various sites. And this is awesome. This proves that the rocket is indeed moving. It is not stationary, although at the moment it is kind of stationary. They've paused in this position. Not 100% sure why, but they are paused right now, just heading down the crawl away. So we will wait to see what happens.
I'm sure it's an abundance of caution. They probably just have to move a few minor things to make sure everything is in the places where it's supposed to be. We were talking earlier that there is a crew on board the crawler, making sure, I'm sure, wires aren't being battered against the side of the vehicle, that kind of fun stuff. You're right. It does show it moving very fast, it looked like, in that video. It's very, very slow.
That was the span of about 2 minutes compressed into, 2 hours compressed into 30 seconds. So yeah, that's a much, much sped up video.
These are just great images of the SLS on that mobile launcher, on top of the crawler, on its way out to 39B. Beautiful, beautiful shot.
The bird's having a great view as well.
Yeah, I noticed that. We were talking earlier about how that's a wildlife refuge over there at Kennedy Space Center. I was there at the end of December and almost hit a javelina on my way in.
We have,
you never know what you're going to see out there.
Yeah, definitely. We have a question here. I don't know if we could go back to the wider angle, but we have a question here from Kaysen, and they're asking, what's the weather at 39B right now? If we zoom out a bit, I think we can see the weather has vastly improved compared to this morning. It's wonderful blue skies.
Yeah, Sawyer was complaining of it being a little bit chilly this morning. I think it was somewhere around 50 degrees Fahrenheit with a bit of a cool breeze. But it's looking like that sun has definitely made an appearance in Florida and burnt off the cloud cover. Looks gorgeous.
It's always wonderful to see the blue sky contrasted by the big orange core stage there. Of course, that spray-on insulation, which is used to insulate the rocket Some rockets, like Falcon or Starship, they don't really bother with any insulation. They just kind of let the fuel tank walls get cold, and that's why we see that frost build up on the outside of the rocket. But SLS and Delta and I think Vulcan even uses it. We have, of course, the space shuttle used it. We have this insulation, which is orange. And along those lines, we have a question from Johan asking, I thought this was the orange rocket. Why is part of it yellow? And,
It will get
well,
more orange, won't it?
yeah, it will, because it's been inside the VAB for over a year. It needs a little bit of a suntan. So the more time it spends outside, the more orange the foam will get, as it will literally be tanned in the sun, which I think is awesome.
I feel like it's the Mar-a-Lago tan, shall we call it?
But yeah, we can see there's two components there. You can see the deep orange of the core stage, and then the kind of yellowy orange of the kind of the connection there between the upper stage. That conical shape is the connection between the core stage and the upper stage. So you can see that the core stage has clearly been out in the sun a little bit more than that conical shape has. That core stage was built at the Michoud Assembly Facility in New Orleans, Louisiana, and it was shipped out to the Kennedy Space Center by barge. I think it was July? Question mark? I can't remember. It was either summer last year or the year before. But it's definitely sat in the sun a little while longer than the connector has.
I believe it's moving again, which is a good sign.
Very slowly, as we have come to expect, but it is indeed crawling along. You have to stare at it very closely to tell that it is moving. But if you scroll back a few seconds, you will notice that it is in a different position to the position it is now, which is, of course, the best indicator that it is moving along. Getting a bit of an LC-39A eclipse right now, basically right in the middle of the Falcon 9 launch tower on the left and the Starship launch tower on the right, recently equipped with its ship quick disconnect arm, we can see there halfway up, which is cool to see. And I think the door to the SpaceX hangar is even a little bit cracked open, which is cool as well.
It's kind of
But there you
difficult
go.
to see from this far away, but very good to see the future of launch on display there.
I think you can also barely see there the tracks of the crawler rolling along. So you might have to squint a little bit to see it on the camera feed, but it is slowly making its way along there. Going to quickly crack open Google Maps and see how far along the crawlerway it is now, because it's just next to those white buildings there, which is a nice little reference point. So I will quickly do a cheeky little distance measure and see how far we are now. About 1.5 kilometers. So they were at 1 kilometer not too long ago. They're picking up the pace a bit. They're making good progress.
They're speeding along. We've
Yeah.
talked about it a few times now, but its max speed when it's got the rocket on board is about 1 mile per hour. We're not expecting it to reach the max speed, so it's crawling at about 0.9 miles per hour when it's at its top speed today.
Slow and steady is the name of the game when you're rolling out a vehicle as big as SLS. It's big, it's expensive. As Jared Isaacman said on
Yes.
social media, if you break it, you're paying for it. And I don't think any of the crew members here can afford another $4.5 billion for a new SLS, unfortunately.
Yeah, I do love his sense of humor with that one, but it's very true. Take your time. This is what it's worth. It's worth doing this right rather than rushing through it and getting anything wrong.
Let's see if there's a few more questions we can go through to ask here. Barefoot Whistle is asking, will we need a fuel stop? And I'm pretty sure that they fully fuel the crawler before they leave the VAB, so they don't need to bring out a tanker truck and refill the tank.
That is the plan, but obviously there is that as an option if they need it to. So we will see. It really depends on how long this whole process takes. We're saying up to 12 hours. They're saying it could be as quick as 10. I know that's a crazy thing to say, as quick as 10. But it really depends on how long this whole process takes, whether or not they need to stop any for unexpected pauses and how long those pauses last for.
We also have Brian asking an update on Sawyer. Sawyer's still there. Sawyer was at the press conference almost an hour ago now, getting the last question in, and he's trying to talk to some more officials as we speak. So I'm not sure if Sawyer will be back
Just
on the
popped into
stream
the
before we
chat.
wrap things up.
He just said, heading back to the broadcast cam. We'll see what's up there and we'll work on some prints for the shop for us. There you go.
Ooh, cheeky preview.
Cheeky preview of what's going on behind the scenes. He's working diligently as they all are over there.
Wonderful. So if we may see him back on the stream perhaps before we wrap things up, which we're not doing yet. So don't go anywhere. Stay with us. We'll continue with the commentary as we watch the Space Launch System roll out for Artemis II. And let's see what more questions we have in here. Again, if you're just joining us, tag us in chat at NASASpaceflight or at NSF, and we will do our best to answer all the questions to the best of our knowledge. Let's see through here. Master IM7JC is asking, I wonder if the SpaceX human landing system Starship will be reusable. If so, how will it be refurbished after a mission? Well, it's not being built with a heat shield, so because of that, I'm going to go ahead and say it won't be reusable in that sense, because if they tried to bring it back to Earth, it would probably burn up, as we've seen on more than one occasion with Starship, it has to be said. So I wouldn't say it couldn't be reusable because they could refuel it in space and then fly it again to land on the moon. But I don't think it's coming back to Earth in one piece. I think would be the safe bet on that one.
These are all great questions, and at the moment we're all speculating of what the answers could be for a lot of this stuff, but we will see.
The only way to get the answer is to watch and find out. It might take a few years, but we'll get the answer eventually. But yeah, these are brilliant questions as always. Oh, we have a great question here from Kaysen. They're asking, has Airbus ever gotten into the rocket part business? Because I know Boeing has, but what about Airbus? And Alice,
Yes.
they have, because they've literally built a part of this rocket. They've built the service module, haven't they?
They have. Airbus Space and Defence is their area of the aerospace area that they cover. Excuse me, I'm losing my voice already. Coughing off microphone. So yes, they are very much involved in the process. There is a lot of companies that have been involved in this. You were listing them off earlier, Ryan. Do you want to go over them again that have been involved in the SLS system?
Yeah, but I mean, there's literally going to be hundreds of subcontractors, which would be impossible to name.
Yeah.
But, you know, we of course have Airbus, who built the European service module, named as such because it is headed by the European Space Agency. That is ESA's contribution to the Artemis program. So that is kind of like a mixed child between the automated transfer vehicle, which used to go to the International Space Station. It also has some shuttle hardware on there. So the thruster, for example, the engine, is a former shuttle maneuvering thruster, which is used for that service module. We also have the solid rocket boosters, of course, from Northrop Grumman, which are produced out in Utah and tested out in Utah. We have the core stage, of course, which was built by Boeing at the NASA Michoud Space Center in New Orleans. I'm also looking at, these are actual banners, by the way, which have been put up around the VAB, and they've been signed by the workforce who actually built the rocket, which is awesome. So these are all the
Love that.
subcontractors with their banners that are up there as well. And of course, we have the Orion spacecraft, the star of the show, the star of the mission. That is Lockheed Martin's capsule, which is, of course, being built by them to be flown around the moon.
Just keep going and going and going. I think it took 100,000 people to get man on the moon in the Apollo missions. I'm not sure the number total at the moment with the SLS system, but there's a lot of people behind the scenes that have been working diligently for years to get this vehicle on the move. It's a very exciting day for them. That's why we're seeing Kennedy Space Center buzzing today with those that have been involved in getting the Artemis II mission on its way to the launch pad.
And it just keeps going.
Keeps going and going and going.
Oh, I see Bechtel and L3 Harris. Those are two companies I recognize. There's
Mm-hmm.
Collins. Is that Dell? I can't tell.
I can't tell either. It's moving between the speed and the size of it on my screen.
It's too
There's
small, but
a lot of companies involved in this, which is great.
Yeah.
And international partners as well, as we've mentioned. So very exciting day for everybody that has worked on this for so long.
One of the great things about NASA is, of course, the space exploration is fantastic, and that's the reason why we're all here. But one of the other great things is that the technology pioneered by everybody who contributes to this mission literally helps to support the economy. If you think of things like flat screen TVs or Velcro or, WD-40, these are things pioneered for the space program, which now go back and help people on Earth. WD-40 is very useful, by the way. But also, literally every dollar invested into NASA produces a $7 return to the economy. So it's literally a 7x multiplier for everything you invest into NASA is what is produced out. So it's a really, really important asset in not only in the US, but also in the world because of all the technology that is being pioneered for the use in space, which then comes back and helps on Earth. Yeah, and then on top of that is incredible scientific discovery.
Mm-hmm. I think we definitely can say thank you to NASA for Teledoc, for example, for anybody who lives in a rural area that has used a Teledoc system. It's been an amazing contribution to our everyday lives.
Looks like we are continuing to roll down the crawlaway, now making our way down that kind of long straightaway, which they're going to be picking up speed to an immense 0.9 miles per hour as they make their way down there. No need for downforce. They're heavy enough as they make their way down the crawlaway. I'd say they're probably just over a mile into the journey now. So they're a bit over a quarter of the way there, I think it's safe to say at this point. That would be accurate considering they've been rolling for over 3 hours, and we're expecting this to take up to 12 hours to get to the launch pad.
I think we'll see it speed up a little bit more now, relatively speed up. Now we're on the straight. It will certainly make their lives a little bit easier. Although we are going to be approaching that inclination that we were talking about earlier, I think we'll be seeing some pauses when they need to readjust the levels.
Yeah, and they also, Charlie Blackwell Thompson said yesterday that they were going to be taking a little bit slower around the corners. So there's the big left turn that comes up. If they continue going straight on, they'd end up at 39A, which wouldn't be a good day. So they turn left and head towards 39B. So there's a couple corners to get that done. So they'll be going a little bit slower around there just to be steady. And this is an animation of that route they'll be taking. So they have that big left turn around 6 or 7 hours or so, which they'll then be taking pretty steady. And then they have that right hand kink before they head up to 39B. And we have just gotten a whopper of a super chat from Chris, which says, someday I would enjoy meeting you all in person and buying the first round. And on top of that, he has done a $500 super chat. And that is just absolutely... Jack did a fantastic job of articulating this. I do a terrible job at articulating this, but seriously, thank you so much for that kind of support. We are pulling out all of the stops for Artemis II. We've got so many people, so many cameras. We've got people joining the team like Alice. We've got so much infrastructure that we are building up to be able to bring you the best Artemis II coverage possible this year. And contributions like this and support like this go so far into helping make all of that happen. So seriously, thank you so much for support. I cannot thank you enough. We're very dedicated. There's a reason we all get up early to watch these rockets roll out. And thank you so much for, to everybody who's simply just tuned in and watched for 5 minutes. Thank you for your support. But seriously, Chris, thank you. That is an incredible amount of support. And we couldn't do this without support like that. And I see people in chat already thanking Chris on our behalf. And seriously, yeah, thank you so much. If you are in chat, make sure to say thanks to Chris, because that is that is pretty incredible.
Chris, you just made my debut. Thank you.
That's a yeah, debut stream, and big support like that. I mean, couldn't really go better.
Well, yeah, I've worked with the guys before and we've done the IREC in the past, but I've never made it out onto your live stream before. So they threw me in at the deep end this weekend, a few days' notice, and I'm very grateful and very honored to be working with you guys. So thank you.
Yeah, I'm going to say it again, but thank you, Chris. For I don't want to sound like a broken record, but that is seriously a really considerable size of support, and we are very, very grateful for that. So thank you so much. And yeah, that is yeah, that's all I can say. It's not enough, but it's all I'm able to say. Also, thank you to John Coaches, who's always in chat, for gifting a Red Team membership as well. So thank you for that, John.
Do we have any more
Okay.
questions from the chat that we can
That's
get
what
through,
I'm
Ryan?
looking for. We've got a few more over the last few minutes, which I'm going to be queuing up here. I'm just having a quick read through to see what else we can talk about. Have a look through here.
While Ryan's looking, I do want to remind everybody this will be going on for the next 12 hours. We won't necessarily be talking for the next 12 hours. At some point, we're going to have to go and get a good cup of tea or coffee, depending on your beverage of caffeine choice. We appreciate the support while we are live today. Watching that bird flying around the SLS, they're getting the best view.
Yeah, I wish we could, strap a GoPro to them or something and get a nice close-up view.
Wouldn't that be something?
Okay, we have a good point here from Psycho pointing out that Northrop also built the launch abort motor, which is another great point. I completely forgot about that. That is, of course, the tower at the top of the rocket there, the big pointy bit on top. That is the abort motor. So, of course, we don't want them to have to abort for any reason whatsoever. But if they did had to, you want to have that option available. So that is basically a really, really, really high thrust solid rocket motor, which will pull the crew away from the rocket in the event that something goes wrong with the rocket and they need to take the crew to safety.
Great point. Safety does come first particularly when it comes to having humans on board these vehicles. We want to make sure that there is an abundance of caution taken for good reason, as we are quickly approaching another anniversary this year of accidents that have happened in the past that we've had to learn from as we move humanity forward.
Yes, they're sad things to think about, but it's very important to remember those sorts of events because by remembering them, it's the only way they're not going to happen again. We have North Richards asking, is it still moving? I think so. But again, it gets to the point where it's so far away that it's very difficult to tell between movement and heat haze, because this is, of course, Florida, where it is very, very humid, and heat haze is a big problem for our cameras.
I still think I'm moving faster than the crawler.
100%.
It's not difficult.
No.
You get a great view there of all of the logos on the side of the vehicle. And you can see the 250th anniversary sign as well, because we are celebrating the 250th anniversary of America this year, which is very exciting. What an amazing way to pay tribute to this great anniversary. And another bird flying in our view. Not sure if that's some type of heron by the looks of things.
I wouldn't mind an SRB birthday candle on my birthday cake.
Wouldn't that be amazing?
It would be a little bit overpowered for a sparkler, but I think it would be pretty spectacular.
Maybe you should add that to the merch requests. Sorry, team.
SRB sparkler.
Yes, please.
Produces 4 million pounds of thrust.
Well, that's only half of what the actual SLS does. 8.8 million pounds of thrust is going to be coming out of that. Wow.
Might be some logistical issues trying to get that one shipped out of the warehouse, but either way.
Minor one. Minor.
Okay, I do want to hit more questions, but literally in the last 3 minutes, we have gotten 5 bits of support, which I have to cover. We have Austin Skirvin with a $10 tip at tips.nasaspaceflight.com. They say, I've been watching NSF since SN15. You have been awesome. The team have changed over time, but the coverage is always great. Thanks for all the Starship/KSC coverage. And that is the reason why we do it, because we are all space nerds. We have members of the team who have been here for a while. We have members of the team who are making their stream debut today, and we have all people in between. So seriously, thank you for the support. And we always try and keep the, even if the people and the voices change every now and then, we always try and keep the same spirit. We're all space nerds at heart, so we're all here for the same reason, and we all just want to bring this stuff to you. We also have Eric Fraser, who is literally a member of our team, helping with the Starbase Live operations, gifting a Red Team membership. So thank you, Eric, for that. We have also have the French Taunter gifting a Red Team membership, and Oren gifting a Red Team membership as well. And we have LPR 180 with a $10 super chat. Thank you for your support. Sipping some coffee, watching from Louisiana. Thanks for all what you're doing. Go SLS, and yes, go SLS indeed. We want to see this thing launch when it's ready, but we want to see this thing launch as soon as possible, because that is going to be, I mean, if I'll be honest, 2025 was a little bit of a bummer to kick things off because we had a few Starship failures at the start of the year. I'm very happy that 2026 is going to be kicking off with Artemis II, because, you know, think of a bigger mission that could kick off a year than Artemis II.
There isn't one. There really isn't. We haven't seen it in our lifetimes. And there's a lot of people out there that have been waiting for since 1972, since the last time we sent humans to the moon. So this is a very, very exciting mission for a lot of very obvious reasons. What a great way, like you say, to start the year.
We've got a interesting question from Luke asking, what is the maximum G-force / acceleration the people on the crawler will experience? I think it's safe to say 1G going straight down. I doubt you're going to be pushed into your seat when driving the crawler.
Yeah. I'm not sure they're feeling anything, let's be honest. I was wondering initially when we could see them up on the tower moving things around, I was thinking, surely that can't be safe. But I honestly think it probably is when they're moving at less than 1 mile per hour.
I mean, that is the point of the crawler, right? There's a reason they go this slowly, and that's so they don't have those forces on the rocket. They don't want to bend it. They don't want it, God forbid, fall over. They want to be really careful, and they want to be really delicate, because this is an expensive piece of hardware. It's a delicate piece of hardware. Yes, it might produce God knows how many million pounds of thrust, but it is a machine you want to protect until launch day. So you don't want to do anything silly that could harm it. Looks like we might be paused again.
You know what? It's probably a gator on the tracks. It happens.
Get the gator across the road. But yeah, you can see very clearly there all the different markings. If you're wondering what those black squares are and those black rectangles, they're essentially different tracker markings. So there are going to be, oh God, I want to say hundreds of engineering cameras dotted around the launch pad, so that when the rocket launches, engineers can basically look at all that footage and triangulate exactly the motion of the rocket based on those different markers. So they're going to be able to use them for tracking and to essentially see how the rocket flew by calculating the gaps and the distances between those different markers and how they're rotating and how they're moving and things like that. So that's what they're used for. They're wonderful tracking markers. And they also, you know, as well as serving that engineering purpose, they also look pretty cool, in my opinion.
Along with the worm, are you a meatball or worm person, Ryan?
This is a great question, and I am going to offend 50% of the community by this opinion. No, I'm just kidding. I genuinely don't have a preference. I love them equally. I think they serve different purposes. It's weird, right? Because they look so different, but they both represent NASA. It's really weird.
Yeah,
but I think
they're
they
both
both
very
do
iconic.
I think they both do a brilliant job at it, and I think they both serve very different purposes. You know, the meatball, I think, works great on the side of the VAB, I think it works great on the capsule, but the worm looks great on the boosters. You know, I think a meatball on the boosters wouldn't look as great as the worm does on the boosters. So I think they both serve, I think they work together, and I think they both serve a brilliant purpose of, you know, being that iconic brand of the agency. And it also looks great on merchandise, you know? You don't see people walking around with US Department of Transportation t-shirts on, but you do see people walking around with NASA t-shirts on. So I think that it does a great job in terms of brand recognition for NASA.
Absolutely.
Just about 4 hours approaching now after first motion. We're just over a quarter, approaching halfway to the launch pad, which is expected to be a 12-hour or so journey. So probably got about 8 to 10 hours left, perhaps, depending on how that's measured. Everyone seems to be saying 8 hours or 10 hours or 12 hours or more. So we're not exactly sure to the second how long it will take. Of course, they need to pause sometimes, like they have now, or slow down for the corners. So it varies, but we're expecting it to be approximately 12 hours, about half a day. So it's a considerable operation and quite a big operation. But NASA, they've done this more than once. They've done this many times before with many different rockets over many decades. So I think we can trust them. I think they know what they're doing.
I'd hope so, wouldn't you? We've been saying this on and off all day, that they have been using this crawler system since the Apollo era. It has done somewhere in the region of 2,300 miles, which is pretty impressive for a vehicle that doesn't actually travel that far, except for on Kennedy Space Center around the complex. So they know what they're doing with it, and it is an amazing engineering feat that it's able to move these enormous vehicles from the vehicle assembly building out to the launch pads.
Indeed. Have a look through here. We have got Barefoot Whistle asking, why is it so far away from the launch pad? Well, I think the simplest way to answer that is, if something were to blow up, you don't want your rocket manufacturing facility to be right next to the rocket that just blew up.
That is the simplest way. Also, when it comes to licensing, for launches, you have to have a fallout area. When you're talking about vehicles of this size, what's going to fall off of it? You expect certain parts to come down. You don't want to have anything in that fallout area, including people, which is why you have to make sure people are stood back behind certain areas when there are launches like this.
Yeah, and there's a reason why the press site, which is where all our cameras are, is right next to the VAB, because that's literally as close as you can get on launch day. Like there's an exclusion zone. People cannot go inside of that zone. So, you know, even people on adjacent launch pads have to evacuate because of that exclusion zone. So everybody needs to be out of the way for the safety of them and the rocket and all of that.
Absolutely. And particularly where we are at KSC, you'll see the waterways all around the place. The vibrations from the booms will vibrate off of those and hit you pretty hard. So I've stood about 3.5 miles away from a Falcon 9 launch with water in between and been hit squarely on the chest from it. It is quite an incredible impact that it really affects people. And I find an amazing way. I'm sure others kind of probably a bit scared by the impact of feeling that on themselves. But yeah, that's the reasoning for it. There is licensing that goes through this process. Obviously, NASA licenses their own launches from their site, but there are safety adherences that they have to make sure they are compliant with. And I'm seeing people buying the t-shirts. And we've got to mention it again. Our merch team have done an incredible job for today.
Yeah, that's another note, by the way. If you don't want to do a super chat or don't want to do a tip or something, if you want to buy something from the store, when we are live, there's actually a little box in the checkout where you can leave a message. So I haven't seen any messages come through, but if you want to leave a message with a store order, you can do that. So feel free. You don't have to do a super chat or anything like that. Or you can just leave a message in the store, or you can just put a normal message in chat. It's up to you. They all come into the queue equally, so we can bring them on screen. But yeah, that is another option if you are interested. Okay, speaking of support, we have got a bit more support because we have Eddie gifting a Red Team membership, that Diabetic Kid gifting a Red Team membership. We have Anna doing a $10 super chat, no message, but just a super chat. But thank you for the support nonetheless. So thank you for that. We have Bob Fillmore gifting 10 Red Team memberships. So is Mimu Maki giving 10 Red Team memberships. Anna again with a $5 super chat saying, at 67 feet per gallon of diesel consumed by the crawler, should we venture a guess of how much has been used so far? Godspeed, Artemis II. Let's have a measure, shall we? How far have they gone so far? I'd say they've gone about a mile. So
I'd
let's
say
Google
about that.
this. How many feet in a mile? 5,280 feet. So let's multiply
By
that
67.
by 67. Oh, okay. That is a big number. That is 353,000.
Ish.
Oh wait, no. Do we need to divide, right? Because I can do 67. Okay, silly me. Ignore me. 78.8. That's the answer we want. We wanted to divide. Live, never do, one word of advice for you, never do mathematics live on air. It is the worst thing you can do. It always ends terribly, and that is a prime example of why we never do maths live on air, because I, of course, meant to divide and not multiply. About 78 gallons, according
We
to
have
that
been up
measurement.
since very, very early this morning as well. It's been worth it. I'm not complaining, but I'm sure your caffeine's starting to run out, Ryan. I know mine is.
Eric says in chat, did Ryan really just have to Google that? I don't know how many feet are in a mile. That's not my fault. I was brought up on a measurement system that makes perfect sense.
I was brought up on both, which really gives away my age, and I still can't figure it out. So
Oh, dear. Okay. I mean, this is just a beautiful shot, right? A mega moon rocket out on its way to the launch pad. Just let this sink in for a moment, because this is just gorgeous, and you've got the sun shining on it as well.
it is absolutely stunning to see it there at Kennedy Space Center on its way to launch pad 39B, where it's hopefully going to be taking off as soon as or as early as February 6th, if they pass all of the testing that needs to be done before they'll be able to take off and launch the first humans to the moon since the 1970s, which is just crazy.
Indeed. And we have Chromatic gifting a Red Team membership, and we have Christina Wells with a £2 super chat saying coverage is brilliant and Alice, you are rocking it. And on a similar note, we have Brian who is asking, for those of us who joined late, could we get the Alice intro, who is our new commentator? So if you wouldn't mind, if you want to reintroduce yourself again for all of the new people who have joined us over the last couple of hours or so, who you are.
Thank you so much, Brian and Anna and everyone who's been contributing. I'm Alice Carruth. I'm the producer of T-Minus Space Daily podcast, which covers all of the happenings in the business side of things when it comes to the space industry. I've been very privileged to work with NASASpaceflight for several years now on the IREC competition, which we host with ESRA, the Experimental Sounding Rocket Association, every summer. It's the world's largest student competition, and I've been working with their live stream team for some time. And Kevin and the lovely John Galloway Das have been asking if I'd be able to come and jump on board and help you guys out for a while. So I'm very, very honoured to come on board as a contributor with you guys for this year. I mean, what an exciting time to come on and talk about rockets and about space. Really, I can't think of a better time in my lifetime.
This is the moment where everything is about to, everything's going to get turned up to 11 and everything is going to go absolutely bonkers because, I honestly feel like once Artemis II goes off, that it's just going to be like a moment that's just going to change everybody's perception, because you'll be able to look up at the moon at night and you will, like Christina Cook was saying in the press conference they held a couple of hours ago, right? You'll be able to look up at the moon and know people are visiting. That is a destination. People have been there within the last few days, weeks, months. This isn't a 50-year-old program anymore. This is today. And I honestly think that is going to be such a big shift in the way that we see things, that everybody's just going to become, 10 times more excited than they already are.
I recently took my mum out to Kennedy Space Center's visitor complex when we were visiting Florida this December, just over the Christmas period. She's never been a space fan, never really been interested in it. But when we started talking about the Apollo program and I asked her where she was, she did remember saying, I looked up at the moon and I was utterly convinced I could see them up there. And I think we're going to see a whole new generation of people looking up at the moon and seeing it in a very different light and being inspired by this movement, and hopefully inspiring the next generation of those that are going to take humanity further than we've ever been before.
The next stop is Mars, and everybody seems to be headed in that direction. Might be a little while before we get there, but if Elon Musk has anything to say about it, it might not be too long with Starship heading that way. Maybe not this year. I think 2028 might be the more realistic target for that one, but we'll go.
He has just recently pushed that back, hasn't he, for that reason. We have to be realistic. We have to take our time to do these things right rather than rushing through and hoping for the best. Nobody wants to see very expensive failures along the way if we can avoid them.
Indeed. Especially with the 2025 that Starship had, I think they might be looking for a little bit more of a successful 2026 with the debut of the new version of that rocket.
The next generation, as we should be calling it.
The next generation of the next generation, which will have everything fixed from the previous generation, as we keep getting told.
What we can do is keep working it, keep figuring out the problem.
I think we might be on the move again. I'm trying to compare the mobile launcher platform to like the edge of our ticker here, and I think it might be moving.
It is so difficult to tell as it is moving so slowly. We keep mentioning it. It does only move at a speed, top speed, when it's fully loaded like this at 1 mile per hour. It wasn't ever expecting to get up to 1 mile per hour today. So we are expecting it to crawl, as its name suggests, at a very slow and steady speed to make sure it gets there safely and all intact, because that's what really matters at the end of the day.
And it is moving, because I've just seen it move across. You see that big crane in the background? It's starting to cover that crane. So a great indication that we are moving along.
Get a nice ad here as well for SpaceX on screen, as you can see their hangar in the background.
Yep. That's where all the Falcon 9s and all the Falcon Heavies and where Dragon gets integrated. And that's where they get, that's their vehicle assembly building, so to speak. That's their integration hangar before they get rolled out to Launch Complex 39A. Okay, I think we should probably hit a few more questions. Whilst we see this Starship Tower eclipse with the ML moving in front of the Starship Tower at 39A. M. Tennies is asking, other than flight hardware, how is this mission different than Apollo 8? And I think the biggest difference really is that Apollo 8 went into lunar orbit, but this time around we're just doing a flyby, right?
Correct, yes. We are not going into lunar orbit with this mission. We're going to be getting us about as close as 7,500 kilometers from the far side of the moon. So it's a slightly different trajectory. I think we've got an image, if we're able to pull it up shortly, to show you what the trajectory is for this mission profile. It's very different from what we were seeing with the Apollo era.
Yeah, Apollo 8 was, I think, apart from Apollo 11, I think Apollo 8 is probably my favorite Apollo mission.
Most iconic, isn't it?
Because it was the first of all, first flight of the Saturn V with humans on board.
Yeah.
That's a big thing checked off the list. The second thing is that it was the first human spaceflight to the moon. That's another big item checked off the list. They orbited it 10 times, and they also did the iconic reading on Christmas Eve, and they did the Earthrise photo. And there's just so many iconic moments from the Apollo program, which all came from Apollo 8. So they pretty much did everything apart from land on the moon, which is, of course, where Apollo 11 takes the cake. But I think Apollo 8 is really... And considering this is my generation's Apollo 8, that's what gets me really excited about Artemis II. And I really hope they have some special things cooked up for when they are flying around the moon. Maybe some special video messages or something like that. Because, of course, nowadays, we have the benefit of HD cameras and much better bandwidth. And hopefully we'll be able to do some pretty cool things with the crew when they are in space.
I'm sure that we're going to get some music played as well. I know you probably remember, but Apollo 8 played Jingle Bells, I believe. They were over the Christmas period, so, why not? I keep seeing these orders coming up in the corner as well. If you haven't seen it yet, go and check out the merch that was released today for the SLS assembly. It is fantastic.
Yeah, it is. It appears to be a very popular design, which is great to see because it means the store team made a good decision and they made a design that people want to buy, which they usually do. Not slanting the store team, they're doing a fantastic job. And of course, if you want to get excited about Artemis II, that's a great way to do it. I will certainly be adding it to my cart at shop.nasaspaceflight.com. another thing, which I believe I saw, is that the crew of Artemis II, I'm not sure, I definitely saw this, I'm not sure if it's still the plan, but at least it was the plan, that the crew of Artemis II, when they are in space, they're going to do a video call to the International Space Station. And I think that is going to be really impressive if they manage to pull that off, because it will be a crew headed to the moon talking to a
Talking to
crew
another
in
crew
low
in
Earth
space.
orbit.
Isn't that amazing?
And that's just, yeah, I mean, first of all, there's nothing cooler than that, I don't think, in terms of a live event in space. Second of all, how impressive is it that we are able to demonstrate our capability of doing a moon mission at the same time as having a permanent presence in low Earth orbit?
Pretty impressive. And I'm going to correct myself with the Jingle Bells thing, by the way. I looked it up because I was like, was it that one? No, it wasn't. It was Gemini 6A that did Jingle Bells in Space in 1965. So don't at me in the chat. I sometimes get things wrong. I'm only a human on Spaceship Earth at the end of the day.
Jake Egan correcting me that it's going to be a voice call, not a video call. But still, nonetheless, being able to talk, two astronauts talking to each other across spaceships, across a few thousand kilometers of distance, is going to be pretty impressive, I think. Okay, let's have a look through here. Have a look through here for some more questions. We have Orion who are asking, can you explain the near rectilinear halo orbit to us? You guys are hitting us with the heavy questions, the big questions today. Essentially, it's a really fancy name for a polar orbit around the moon, which guarantees that there will always be or as much line of sight to the south pole of the moon. So it's the orbit that the Gateway space station is planning to use, and that is to allow communications to the south pole of the moon, which is where everybody wants to land, because there's confirmed water ice there. Water is really, really useful. If you didn't know, water can obviously be used to drink. It can be split into hydrogen and water. Into oxygen. Oxygen is wonderful to breathe. It can also be used as an oxidizer for spacecraft. Hydrogen can be used as a fuel for spacecraft. So it's a really useful commodity to have access to. And it's nice to not have to ship everything from Earth to the moon, right? They'll actually be able to do in situ resource utilization, which literally means living off the land, which is, if you want to establish a moon base, being able to live off the land is pretty important. Okay, let's have a look through here for some more questions. We also have Blair, who is asking, who from all the team is planning to be there for the launch? I don't have a list yet off the top of my head, but I do believe as many people as possible are planning to attend. We will have, of course, we'll have God knows how many live video cameras. We'll have photographers, we'll have commentators, we'll have hosts. But of course, we'll also have the entire NSF team, not necessarily there in person, but also working the launch as well. So, but like, I can assure you, if you saw our Artemis I coverage, we had so many people out there at the Kennedy Space Center. It's going to be very similar again. We're going to have so many people out there for this launch because it is so exciting. It is like it is the moment of the 20th century so far, in my opinion, in terms of spaceflight. It will probably be topped by Artemis III. But at least for missions that have flown to date, this will be the biggest one of the 20th century. So we are going to be shipping as many people as we can out to the Kennedy Space Center to bring you guys the best coverage possible so you can watch it all around the world.
Hi, Ryan.
And hi, Kevin. Well,
Before you do what I think you're going to do.
Yeah.
I just want to talk about, so over the last 2 years, I've been with NSF for 3 years now. I guess 3.5 years now. Over the last 2 years, we have been working on a major infrastructure project to upgrade our capabilities at Starbase, at KSC, at the port. So you were talking about like a lot of cameras going out, and yeah, we're going all out, Ryan. We have to go all out. Like you brought it up that this is the biggest launch in your lifetime. This is the biggest mission in your lifetime so far. You have a lot more ahead of you. This is the biggest mission for us too. I think even right now. I think it's bigger than Starship. Um, this is an amazing moment in history, and we have been doing everything we can to upgrade our infrastructure to make sure we can support as many cameras as possible. And everybody is going to be out there from our team. Everyone. I mean, people are coming from Starbase, and hopefully nothing happens at Starbase while this is launching. But I mean, we're going all out. And it's because of everybody who comes here and watches us. I mean, there's been 6,000 people constantly on this stream. On Facebook, we're having our biggest stream ever on Facebook, where almost 1,000 people showed up to watch on Facebook, and that's awesome. And then also on X, it's because people are always coming out and supporting us just by watching. And I think the biggest thing that everybody that's watching can do today is go tell your friends, go tell your parents, go tell your brothers and sisters and cousins that there's a big orange rocket at Kennedy Space Center right now that's going to the moon. It's going to the moon. And that's crazy. And then tell them to come watch NSF, because
Evan, you sound a little bit excited.
I am so excited, Alex. I am so excited. This is what we've been waiting for. This is why when I was a 6-year-old sitting in Connecticut in my bed, I had wallpaper with astronauts and the moon and the stars on it. Like this is what we've been waiting for. And it is so exciting. It's so exciting that for 4 hours and 19 minutes and 40 something seconds or 50 seconds, we've been watching this thing move at like half a mile an hour. Because that's going to the moon. And it's going to go a lot faster than that when it goes to the moon. Right? Yes. Moon. I see chat. Chat's getting excited. Ryan, I'll let you go back to your business, but I'm going to stay here because I also want to say something else at the end.
Okay, Kevin. Kevin joined me just as I was transitioning to do another store plug for all of the people who enjoy the behind-the-scenes knowledge. So, very nonchalantly, I'm going to say we have a new print on the store, and that is, of course, a print of SLS making its way to the launch pad. This beautiful head-on perspective, courtesy of the one and only Jerry Pike, who has been out there working some of the cameras for us today. And that is now available at shop.nasaspaceflight.com. I know, it's just absolutely spectacular. You can get this on a metal print or a paper print, and you can get them in various sizes as well. So if you want a picture of SLS on your wall and you haven't got one already, or you want another one, that is a option for you there on the shop. So there you go. And that is just an awesome head-on view of the rocket, and it's almost perfectly symmetrical. I think that's pretty much as symmetrical as you can get whilst being on the properties we are allowed to be on.
And Ryan, don't forget, our photographers get a cut of every sale. And our photographers buy their own equipment. So that basically is just reinvested in buying more equipment so they can get more great images like this. And I believe Sawyer has one coming out soon too, but
Yes, he's
that's not
working on
quite ready
uploading it
yet.
right now.
It's
Yeah,
coming.
exciting.
It's coming.
So stand by for that if you want a second print. if you want all the SLS prints, stand by for that as well. And yeah, I can. I have never set launch remote cameras for a launch before, but I can assure you that sometimes big rockets means that cameras no longer survive, and sometimes cameras go bye-bye after a big rocket launch. So every now and then our wonderful photographers have to purchase some new equipment, and the sales from those prints really do go a long way to supporting those individual photographers. So if for some reason you really like Jerry, you can buy some of Jerry's prints, or any of our other photographers, awesome photographers working for NSF, which you can get at the shop as well. And whilst we have the opportunity, I think I might just try and hit a couple more questions. Or first of all, we have Chris W with 5 gifted Red Team memberships. And then we have Methane Man with a $50 tip. saying Kevin
Thank
doesn't
you.
sound excited at all.
No, I'm not. We're going to the moon.
You need to go an octave higher, Kevin.
I don't know if I have that extra octave.
Yeah.
It's still too early. I'm telling you, I'm running on caffeine alone, my friend. And I'm super excited for it. I wouldn't have it any other way.
Yep. Sometimes you just kind of have to accept the fact you're not going to sleep very well the night before, get up early and watch a moment of history being made. And today is one of those days.
Isn't it? It's a moment in history. We're seeing the first vehicle rolling out that's going to be taking humans to the moon since 1972. I think we just have to keep reminding ourselves that this isn't just your average spacecraft that we're seeing, and we are seeing an incredible launch cadence now. Even in our lifetimes, it's gone from next to nothing to almost every 3 to 4 days out on the Cape. But this is something different. This is something so much more.
Yeah, it is truly, 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 truly spectacular. Sorry, I was just liking Jerry's promotion on X of his new pad-bound metal print. There we go. Just do a cheeky like there, and back to the show. We're back in the room. Okay, what else have we got to talk about? We've got another question here from Arturo asking, how tall is Artemis and how big are the boosters? If you mean the SLS rocket, the Space Launch System rocket, this is the primary crew launch vehicle of the Artemis program. So overall, it's just under 100 meters in height. It's about 98 meters tall. And the solid rocket boosters, if you think of them they're a similar size to Falcon 9 boosters. So they're about 3 meters wide and they're a similar height as well. So just for a bit of scale of how big this rocket is, it's essentially 2 Falcon 9 size boosters strapped onto the side of a 98 meter tall rocket. And that's pretty impressive in terms of scale.
For those of us over here in the US, that's 322 feet. There you go. I do have my moments where I remember both systems.
I always struggle with the conversions, so I always stick with one. And as demonstrated, 20 minutes ago, doing Maths Live is never ends well.
I feel like everyone needs to start asking us more questions and push Ryan's math knowledge. We're learning. We're learning with you, my friends.
Okay, let's have a look through here. If there's anything else to talk about whilst we have the opportunity to. This is a great question. This is something Philip was talking about earlier. And we can they're very small. Well, again, they're not small. They're small in relation to the rocket. They're kind of small in this perspective. DOS Addict is asking, what's up with the new core stage chines? And I don't think they're called chines. I think Boeing are calling them strakes. But I think basically what happened on Artemis 1 is they saw a bit of drag building up in that area. And one of the ways they're trying to mitigate that on this flight is by putting some new strakes by the nose cone of the solid rocket boosters on the core stage. So in that gap, if you can imagine, they've filled that in with a strake to try and limit drag and just, make the whole thing a little bit more streamlined and make the turbulence a little bit less turbulent.
Yeah, reduce
That
those
makes sense?
vibrations. Yes. You're in
Yeah,
ascent,
just make-
obviously.
Yeah, just make the ride uphill a little bit smoother than it perhaps was on Artemis 1. So that's why those have been added there. Oh my goodness. And we've got another tip. The support today has just been incredible, guys. Like, seriously, thank you so much.
Yes,
Simon
thank
the
you.
Mac, who is who's a member who's helped us in the past, especially with the UK meetups, with a £20 tip, saying, you guys are amazing. I'm enjoying watching or putting the final touches on the Lego Artemis launch system. And
I
if you
think
didn't
we
see
need to have
it,
some images of that, don't you?
100%, because if you didn't know, Lego recently revealed a new Artemis inspired set, and it's Lego Technic. So if there's like a handle on it, and if you wind it up, like, it literally launches the rocket and the solid rocket boosters come off. It's so cool.
That's amazing. Simon the Mac, send us your pictures when it's finished.
Yeah, definitely make sure to put them in the member Discord because I believe you are in there. So make sure to share them with us when that is complete, because that's another thing with NASA outreach. Like, we can be critical sometimes. Maybe they should have been hyping this mission up more than they have been. But on the other hand, they have so many cool Lego sets. I mean, there's been space shuttles, the space station, Saturn V, lunar rovers, lunar landers. Like, there's the lunar module, there's the Hubble, there's the Perseverance rover. They have so many. They've done so many cool sets, which again I think is an awesome way of spreading the word and getting people excited about space. That's just I think that's a great way that NASA has been working on that.
Absolutely. I'm looking for Gator Watch at the moment. We've got that gorgeous view. You never
Yeah.
know when you're going to spot a gator when you're out at KSC. So this is definitely the Gator Watch view.
American rocket and the American flag and an American waterway in between. That's the Turn Basin, which is the core stage has actually arrived. That's how the core stage came to the Kennedy Space Center. It rode a barge up that very channel up to the dock and then was unloaded on NASA's Pegasus barge, the big enclosed barge. So this rocket, in a way, has technically traveled along that canal, which is pretty cool. And it's now going back the other direction along the causeway next to it.
And it's worth reminding everyone that this rocket is also carrying the 250 logo because this year is America's 250th anniversary. So what a great way of celebrating by being able to say we're returning humans to the moon.
Indeed.
Hey Alice, I just noticed a comment on Facebook on our stream
Oh
there.
no.
Someone said, "Great to hear your voice. You gave me a tour of Spaceport when the space hipsters visited."
Yeah, I did. I used to work at Spaceport America. I was the public information officer over there. So when I talk about, stabilizing the road with water because of dust, I've spent many a time having to deal with that out at Spaceport. So same with licensing. Unfortunately, had to learn a lot about that. It's very nice that people recognise me. There aren't many British people that work in the space industry, so I have had a bit of a reputation from the last 10 years of working over here in the US. And whoever that space hipster is, it's very nice to hear from you too. I did notice, I don't know if you saw in the presser there, Ken Kramer and Gene Wright, the OG space hipsters. I have spent much time with Zarellas over at Kennedy Space Center. It's very good to see them on camera.
Yeah, it's always wonderful to see everybody turning up for these events. There are so many people showing up, not only from the workforce bringing their family and friends along to watch the rollout, but also from the media. There are the folks like us which are out there night and day for the 3 a.m. Starlink launches, bringing you all the coverage as we do. But it's also nice to see the place get busy sometimes for these big events because it means the world is watching. And, come February 6th or whenever they launch, the world will be watching. And everybody will be keeping an eye on the Kennedy Space Center. This is that very... maybe it looks like some people have decided to go home at this point, but... that car park is still very, very, very full. Usually there's about 3 cars parked there. There are much more than 3 right now. So that's wonderful.
There was a lot more this morning, though. I think they were really wanting to see it come out of the vehicle assembly building. I mean, that is an iconic building. So to see it finally reach daylight was definitely... my news feed on LinkedIn this morning was just absolutely chocker, full of people who were there, like you say, with their friends and family, excited to finally see the SLS roll out, excited to see their hard work finally being moved to the launch pad in hopes that it will be taking off in the coming weeks. Yeah, it's funny to watch those buses pull away. They're done.
Definitely.
They're done with the crawling.
Yep. They've had enough. Something else we have for you is that aforementioned metal and paper print from Relativity. Whoosh. There we go. Oh, that's a beautifully framed picture there.
Beautiful.
We've got the rocket on the launcher, on the crawlerway, with a beautiful reflection in the turn basin, and we've got some greenery in there as well for good measure. That's a very pretty shot from Sawyer. Now available at shop.nasaspaceflight.com. Again, you can get it on paper or you can get it on as a metal print. It's literally printed onto metal. It's really high quality stuff. So if that's something that takes your interest. Remember, a cut of all of the print proceeds goes to the person who took the photo. So Sawyer took this one. So if you decide to get this print, a portion of that will go to Sawyer to help him get more equipment as well. So keep that in mind when you are purchasing your prints. But yeah, that is a very pretty print indeed. Again, highly recommend you get that one. I can't tell. Is that a bird caught in the bottom corner as well? I'm going to hang on. I need to open this in full screen and have a zoom.
Zoom in. I love the title of it, Nature versus Future.
Oh, it is a bird, but it's on the water. It looks like a heron or something, maybe, swimming on the water. Very cool. So we've got some wildlife in there as well. There you go, zooming in. There you can see just there.
Buy it for the bird, and then you get the bonus of SLS in the shot.
Yeah, buy a bird, get an SLS free. But there you go. And we got some blue skies as well, finally.
Yeah, it wasn't so blue this morning. It was a little bit cloudy, which was a bit concerning, but as Florida is always the sunshine state, it did come through for us. Just to show off, they've got even more blue.
Yeah, barely a cloud in the sky.
Hey, Ryan, I did see a comment, which I just want to correct. I saw it in chat on YouTube. Someone said that it has to roll back to the VAB for FTS installed. And that's actually incorrect because the FTS is already installed on SLS for this flight.
Yeah, and they even did some upgrades between Artemis 1 and Artemis 2. You might remember last time around, they had to roll back because basically the flight termination system on SLS, they use a completely independent power source. So in the event that the rocket loses power for whatever reason, the flight termination system can still do its job. So it's super redundant in that sense, but that alternate power source are batteries, and eventually the batteries are going to run flat. So you might remember on Artemis 1, they were out at the pad for so long that the batteries for the FTS ran out. So that's why they had to roll back to the VAB to essentially charge up the batteries. This time around, though, they've added a new platform to actually access that area of the rocket on the launch pad itself. So they can access the flight termination system for Artemis II on the launch pad. So if that were to happen again, they no longer have to roll back to the VAB. So that's a much more simplified procedure, let's say, than rolling all the way back 12 hours to check the batteries and roll all the way back to the pad for 12 hours. So that, saves 24 hours of rolling if you don't need to.
Goodness knows how much fuel.
Indeed.
That was me trying to get you to do another calculation, Mariah.
I've learnt my lesson for today.
Okay.
Very briefly, we've got one final super chat from Alter Histories for the, is that Czech currency? Let me check. Let me check, but accidental pun. Yes, 1 Czech koruna. Thank you very much for, 200 Czech koruna. Thank you very much for your support. They just said, I love all your streams, all information and knowledge. It's just awesome. Thank you, guys. Well, thank you for the support. Thank you for tuning in. Thank you for watching. It has been wonderful to be talking with you for the last almost 5 hours at this point. And speaking of thanking people, I think it's an appropriate time to thank our field team who have been out in force today. We had Sawyer Rosenstein on commentary earlier with the cameras as well. We also had a Jerry Pike on the cameras, bringing us the best views. We had Philip Sloths bringing us all of his knowledge. He knows so much about SLS, like you can literally pick his brain for hours. It's incredible. We have, of course, also had Jay Keegan in the background, pressing all the buttons, making sure we get all of the photons to your eyes, all of the live views as well. Also, thank you to our Space Coast Live team, as always. These guys operate the robotic cameras, and we've been mixing those robotic cameras in for this stream, which has been great. And of course, I want to thank Alice, making an NSF Live debut. Welcome to the team, and thank you for being on the stream.
Thank you, Ryan. I've really appreciated it, and I hope everyone's had a lot of fun with us today.
Hey Ryan, I want to jump in really quick because I know we've thanked Alice already, and she's mentioned where she's come from and that this is her debut stream. I 2 years ago, I was out at IREC at Spaceport America, assisting the video team out there. Me and Doss went out that year, and there was this woman who was talking for like 12 hours a day on the IREC stream. And I said, we need to get her to work for us because she is so good. And I am so happy that this day has finally come. And I want to welcome you to the team, Alice.
Oh, thank you, Kevin. I really appreciate it.
And with that, I've been Ryan Caton for NSF. Thank you for watching. But stay tuned, because we're just going to stop talking, because my voice is starting to go. We're gonna we're gonna continue with the live views, but we're gonna be carrying this all the way to the launch pad. But yeah, in terms of commentary, thank you very much for joining us, everybody, and we can't wait for Artemis II. Bye bye.
As the sun sets in Florida, the moon is currently 247,391 miles from Kennedy Space Center. You aren't imagining things. This is your television or your other electronic device talking to you. Actually, this is Kevin, producer at NSF. The rest of the team has gone home to catch some sleep after a super early morning. But Jay, Gage, and I have hung out to keep the views going. Yes, I see you, chat. I see you. You also aren't imagining that on this day, the 17th of January, 2026, your Mega Moon rocket has been delivered to Launch Complex 39B at Kennedy Space Center. For the first time since 1972, a rocket which will launch humans to the moon is now on the launch pad at Kennedy Space Center. Before we sign off on this stream, I want to remind you that we will have 24/7 views on Space Coast Live, and of course, dedicated live streams throughout the Artemis II campaign. A quick thank you to our teams in the field and in the studio for bringing you today's stream. Ryan, Alice, Philip, Sawyer, Jerry, Gage, the Space Coast Live team, and of course, Jay Keegan in the control room. And I want to take this final moment to thank you for trusting NSF for your spaceflight coverage today and throughout the testing and launch campaign of Artemis II. It really is a time to be alive. Don't forget to tell everyone that there's a moon rocket on the pad at Kennedy Space Center, and we're going to the moon.
And here we go.
There's the W. Here's ignition.
Roger roll, Atlantic. Doubling up.
Did it just do a Kerbal? Back to the moon and beyond.
Put that in the big bag, Gino.
Back at home, we all have a lot of work to do, but from here, that sure looks like a perfect flow.
Propulsion continues to be normal.
We did have an observation. 343 unfolds to go.
It's orange!
Water towers can fly! Bingo! Right in the center. Where's Jacqueline? There it is! That was surreal.
That's not what we want to see.
No!
Oh my God.
Yikes, you bet. We don't need any more of these.